He watches a planet learn the skill of cooling. Heat loosens its grip on a globe still flushed from assembly, and light leaves in long waves that slip into the dark between stars. The crust is a film that keeps trying to exist. Fresh melt stiffens, splits, and founder blocks return to depth like heavy rafts sliding off a winter river. Above, a dense atmosphere collects from 1,000 open throats. Steam crowds with carbon dioxide and sulfur-rich breath, turning noon to a pewter glow. The sky is not decoration. It is a shield and a trap, keeping warmth near the surface long enough for rock to rearrange itself into forms that can endure contact with water. Inside the mantle, motion begins as a quiet circulation. Hot rock rises in slow pillows, spreads beneath the surface, and sinks where it cools. The pattern is not symmetrical. Some currents outrun their neighbors, some hesitate, and the skin above them records each difference as faint relief. Valleys are not yet carved. They are sags born of contraction. Mountains are not yet lifted by collision. They are swells where magma ponds and hardens. Through these reliefs, the globe practices contrast. That practice will be the key to everything. Condensation chooses its helpers. Volcanic ash and sea salt crystals lofted by violent boiling give vapor something to cling to. Droplets grow, collide, and fall. At first they die in midair, turned back into steam by the fevered ground. Cooling inches forward, a threshold is crossed. Raindrops strike stone and stay liquid. The sound is delicate from far away and fierce at the point of contact, a vast whisper made of countless impacts. Each drop steals heat by conduction and by the secret transfer hidden in a change of phase. Big basins do not yet exist, so water spreads in sheets, then finds cracks, then knits those cracks into converging threads. The threads swell to channels. Channels link into networks. A world that had only upwellings and collapses now acquires a new geometry that moves under gravity alone. The first standing water is dark and hot. It carries dissolved metals stripped from fresh basalt and accommodates gases still bubbling from the floor. Where it laps against the ground, new minerals precipitate like frost on black stone. Where it finds deep fractures, it sinks and returns as hot fountains, a circulation folded entirely within rock and water. At the ends of these loops, chimneys grow by accretion. Their walls are fragile, their interiors are porous. Fluids move through them in tiny pathways that sort temperature and chemistry into stacked layers. No organism waits in those layers, yet the gradients act with purpose. They store energy as difference and spend it in reactions that leave traces mineralized into the cathedrals of vent fields. The moon hangs nearer than any later eye will know. Its pull stirs the sea into bulges that travel faster than old continents would later allow. Several highs and lows cross a young shore between sunrise and the next dawn. The rotation of the planet is swift. Daylight sprints, night falls quickly, and winds chase the temperature boundaries with impatience. Under this tempo, the seam between land and ocean is a belt, not a line. Water moves sand and shattered glass in sheets that wander sidewise. Rock gives way in plains where cooling joints pre-arrange the next failure. The boundary is noisy, but the noise is patterned, and pattern is a promise that forms can last. Pieces of crust begin to differ in density, where melts evolve by fractional crystallization or by the addition of water dragged downward along deep cracks, paler magmas separate from darker sources. They rise and freeze into light-toned rock that floats higher than basalt. Fragments of this buoyant material emerge as islands with flanks that slope more gently into the sea. Waves refract around them, focusing power on their headlands and calming the embayments between. In those calm corners, sand lingers. Grains rich in quartz survive grinding better than mafic fragments and give beaches a brighter face under thin sunlight. Texture and tone on a shore begin to tell the composition of the rock it feeds upon. Air learns to scatter blue. As ash and aerosols wash out, molecules dominate the column and send short wavelengths sideways with efficient grace. The sea answers by absorbing red and returning the rest in proportions tuned by depth and clarity. The color shift is not a flourish, it signals a changed energy balance. More light returns to space from bright cloud tops. More heat sinks into the upper ocean where water can store it and carry it sideways. Winds respond by choosing lanes. Convergence rises near the equator. Descent settles at subtropical belts, and a planetary engine starts to push heat poleward. Swells assemble over long fetch. They travel with long periods and meet the shore as ordered processions rather than chaotic slaps. Rivers refine themselves from sheets into threads with memory. Chemical weathering supplies clay that gives banks cohesion. Channels narrow, deepen, and fasten to predictable curves. Outside bends bite into rock. Inside bends gather bar forms that migrate in graceful steps. Floodplains accept their role as archives. Each overbank event lays down a flat leaf of silt that captures the height of water and the fineness of particles for that day. At mouths, the rivers try out every grammar the coastline offers. Where waves dominate, slender spits hook landward and crate lagoons behind a line of breaking surf. Where tide dominates, branching channels spread into maps of inhalation and exhalation. Where discharge is king, lobe-shaped deltas push into the sea and collapse later under their own weight, only to be rebuilt by the next pulse. The ocean keeps its accounts accurately. Rain spiked with carbonic acid extracts, sodium and potassium from feldspars, calcium and magnesium from mafic minerals, and iron from nearly everything it touches. Chloride arriving from volcanic sources balances charges. Salinity climbs toward a level at which inputs and sinks compete to a draw. In warm shelf water, carbonate wavers near saturation and plates thin skins on grains and ledges. At hydrothermal sites, silica gels into opaline crusts that trap earlier textures like a snapshot. Cement appears and disappears. Cohesion strengthens and weakens. These shifts decide whether a cliff yields by slabs or grains, whether a bar holds shape through a storm or migrates in hours. From the core, a magnetic field unfurls like an unseen tent. Charged particles from the star would strip the upper air and ruin the experiment of oceans if not turned aside. The shield holds enough to matter. With it, the atmosphere lasts, the water cycle repeats, and the coast has time to practice style. At high latitudes, aurora lift curtains of colour over clouds, and though no eyes watch, their glow hints that the engine below is awake and lending protection from above. Impacts continue in a tapering cadence. Some strike the sea and leave only rings of foam and columns of steam. Some hit land and excavate basins that fill with hot rain. Terraces ring those lakes as levels settle, steps that can be read as a chronology of retreat. When outflows cut saddles in crater rims, new rivers sprint downhill, carving gorges that transfer the violence of an instant into centuries of erosion. Even the interruptions function as sculptors, adding variety to the routes water can take toward its wide home. Sound changes from riot to measure. Breaking plates and collapsing lava benches still speak sharply, but long-period swell writes its own line in the composition. Sets arrive with steady spacing. Each wave steepens, feathers, and folds. Foam runs up dark sand, hesitates, and slides back, drawing a rattling tail of pebbles. On moderate beaches, rhythmic cusps appear, scallops evenly spaced by the standing choreography of edge waves. The shore invents geometry in response to repeating force, proof that beauty often begins as a byproduct of function. Morning builds a horizon that looks newly precise. Light steps across water like a practiced dancer, then climbs rock and finds the pale spray that marks every impact. Along that arc, the planet presents its first credible margin. Nothing absolute divides sea and land. Everything negotiates. Rock brings fracture, stiffness, and grain. Water brings height, period, and density. Air brings pressure, temperature, and momentum. Heat threads through all of them as radiation and vapor and cloud. Their meeting drafts a form that endures by changing. In that form, he reads the premise for continents and oceans, not as names on a map, but as habits of matter that will persist long after the last plume has faded and the last ash has settled. He follows a convoy of field trucks into a red interior where stone keeps a memory longer than rivers. Western Australia opens in low ridges and dry creek beds. a country where quartz pebbles crunch underfoot and heat lifts in ribbons from iron-rich soil. Here, a belt of ancient conglomerate hides grains so small a fingertip could cover a dozen. A hammer taps once and then again. A geologist kneels, tweezers in gloved hands, and lifts a clear shard the size of a sand grain from crushed rock. It glitters without fuss. Zircon, tough as a vow, ready to testify. The story begins in outcrops named for the Jack Hills. The rocks are not pristine crust. They are river deposits that once carried detritus from uplands now gone. That is their advantage. Rivers are indiscriminate archivists. They mix fragments from many sources and lay them together where a careful eye can find what single outcrops might never reveal. In these beds, detrital zircons gather like seeds in an old granary. They are not valuable for beauty, but for clocks they hold inside their lattice. He watches work move from sun to fluorescent lab light. Crushing mills turn cobbles into grit. Heavy liquid separations coax denser minerals into a narrow fraction. Under a binocular microscope, tweezers pick zircons one by one, favoring grains with sharp edges and internal zoning that promises a clean record. Each grain is mounted in epoxy and polished so that its interior is a flat window. The scene shifts again to a room that hums with vacuum pumps. An ion microprobe points a focused beam of oxygen or cesium at the target, sputtering atoms from a tiny pit. Detectors count isotopes with a patience that would embarrass any clock on a wrist. Numbers arrive as ratios that invite translation into time. Zircon admits uranium into its crystal, but turns its back on lead when it forms. Later, uranium decays and lead accumulates. Measure both, and the mineral tells its age. The surprise lands as a date that reaches past 4 billion. A grain reports 4.2 billion years. Another, 4.3. Then, a small crystal gives 4.4, a number written with the cool certainty of a half-life. The lab falls quiet for a moment that feels like wilderness inside a building. If true, these ages mean crust existed when the planet was still swaddled in heavy air and frequent fire. A second instrument turns to chemistry that speaks of temperature and water. Oxygen comes in flavors, heavy and light, and rocks record which flavor touched them. When zircons grow in magmas that interacted with water-altered crust at low temperature, the ratio shifts to heavier values. A suite of Jack Hill's grains carries that signal. The implication is audacious. There was liquid water on the surface, while impacts still scarred the sky. There were cool places where continental ingredients had begun to collect. The grains speak without drama. Their isotopes align and say a simple thing. Ocean existed, and rock met it. He travels in mind to the Canadian Shield, where polished lake country wraps around outcrops of banded stone. Far to the north, the Acasta Gneiss stands in light that arrives only after long winter nights. It is not the oldest archive, but it is a body of rock, not a single sand grain, and it tells a coherent story. At 4.02 billion years, it records melting and recrystallization in deep crust, the slow operations of heat and pressure that build buoyant blocks. The outcrop is a map of stress written as veins and folds. A hammer blow here brings back a sound that rings differently. It sounds like continuity. Across the ocean, on the shorelines of Hudson Bay and into northeastern Quebec, a different candidate steps forward. Greenstone belts and tonalite plutons fold together in a pattern that hints at early cycles of burial and rise. A group of rocks earns an age that pushes beyond 4.2 billion when measured by the method that reads the conversation among samarium and neodymium. The number is debated. Was the age inherited from older material or forged in place during a separate event? The argument is not a distraction. It is the way truth gets weight in this field. Measurements are repeated, assumptions are inspected until they squeal. The value of the debate is that it keeps everyone listening to the rocks rather than to the momentum of hope. He moves next to Greenland, where ice trains the eye to distinguish subtle shades of grey. There, a belt of metamorphosed sediments and volcanic rocks stands near fjords that slice like blue knives into bedrock. Within the Isua belt, Carbon sits in graphite that is isotopically light, a signature consistent with biological fractionation, but also obtainable by non-biological pathways in a hot world. More important for the present mystery, pillows of basalt and layers of banded iron suggest a working ocean by 3.8 billion years. Water circulated. Lava met it and froze into shapes that can only grow underwater. Iron alternately dissolved and precipitated in response to changes in chemistry and redox state. The belt reads like a shoreline archive, without any need for a coast to be near today. Back in Western Australia, a thin section glows under cross-polarized light. A zircon reveals concentric zones like tree rings, each layer a slightly different chemistry. Titanium content, measured in microscopic spots, serves as a thermometer because titanium wants to enter zircon more at high temperature than at low. The readings imply magmas cooler than the wild temperatures of early ultramafic eruptions. The magmas look more like the ones that feed continents. The inference is not a story of continents finished and large. It is a sign of differentiation, of distillation toward lighter crust that will one day resist submergence. Names accumulate, not as statues, but as coordinates for a movement. Field geologists kneel in dust at Jack Hills with sieves and maps. Instrument builders design microprobes that can count the rarest isotopes without losing patience. Geochemists gather around plots where error bars are bigger than pride and decide whether a cluster is genuine. The personalities could not be more different. Some love sunrise on a granite dome. Some love the click of a vacuum gauge settling to spec. Together, they triangulate a narrative. Early coolness existed, water endured. Chemical weathering started to build a supply of ions that would salt the sea. Light-toned magmas rose from darker sources. He visits one more archive, lying not in rock, but in the characters of minerals that resist change. Zircon carries trace elements that whisper the identity of the melt. Aluminum in the lattice can pair with phosphorus or with trivalent cations, and those pairings hint at whether the source was a deep mantle plume or a remelted crustal reservoir. The earliest grains favor signatures that demand some participation of older, altered material. Even in this young age, recycling is already part of the system. The planet learns to use its own products as ingredients for the next meal. The discoveries do not arrive as a single trumpet. They come as a choir of precise notes, each quiet alone, persuasive in harmony. Dates etched by uranium and lead, temperatures read by titanium, isotopic flavors of oxygen that require water-touched crust, geometries in gneiss that preserve the push and fold of long-buried material, pillows and iron bands lifted from ocean floors and pinned by metamorphism into hills. None of these on its own can certify the birth of continents and oceans. Together they insist that edges were possible far earlier than caution once allowed. Dusk returns to the field camp in the red interior. A sample bag lies full on the table, tagged with coordinates and elevations. A notebook fills with sketch maps and a list of grains saved for later. A moth beats against the lamp while the sky cools by degrees. The small crystal in its capsule of epoxy waits for a beam that will liberate atoms in a clean plume and send a history to a screen. In that waiting, he hears a calm claim. The planet kept a record of its first edges inside its smallest survivors. Those who listened closely found that record and learned to translate it into time, temperature, and water, the three measures that matter for the beginning of continents and the making of seas. He opens a ledger of assumptions and finds the numbers wrong. A young world, by every tidy calculation, should have stayed too hot to keep rain, too battered to keep a crust, too smothered by impacts to hold an ocean that lasts a season. Heat production from short-lived isotopes should have kept the mantle soft as taffy. The surface should have worn a rigid lid that healed every crack before it could become a fault. Under a sun that delivered less than 3/4 of its later light, open water should have frozen at the poles and crept equatorward until even the tropics carried ice. The consensus wrote a simple morality tale: fire first, oceans later, continents last. Then the evidence walked in, quiet and precise, and refused to fit the script. Zircon grains, barely larger than sand, tell temperatures that fall in the range of crustal magmas rather than furnace flows. Their oxygen isotopes tilt toward values that require water-altered rock, not dry mantle. They could only have grown in melts that had met liquid and cold enough crust to hold that liquid without erasing every trace of the meeting. The conclusion feels almost impolite. Water took up residence and stayed. Cool surfaces existed while the sky still carried ash and lightning as a second language. The shock is not only temporal, it is conceptual. Oceans were not a final adornment. They were ingredients that joined the recipe early enough to change what rose and what sank. Granitic relatives, those pale tonalites and trondhjemites that float higher than basalts, appear in ages that crowd the boundary between myth and record. They demand a mechanism that concentrates silica and alkalis from a mantle that began iron-rich and volatile poor. The familiar route involves subduction, hydration, and melting of basaltic slabs. Models kept the first global conveyor off the table for a long stretch, because hot crust should be too buoyant to dive and too weak to drag anything downward. Yet the rocks whisper about remelting, about water lowering melting points, about residues left behind that match petrologic experiments. It is as if the planet skipped rehearsal and went straight to complicated choreography while the orchestra still tuned. A second contradiction arrives from the sky. The faint young sun hangs low in brightness, yet rivers carved and rain fell, and seas did not arm themselves with ice. Greenhouse gases must have stepped in as a blanket thick enough to keep the water phase stable. Carbon dioxide, methane from a mantle that still exhaled reduced gases, even hydrogen that escaped slowly as the upper air bled to space. Each contributes a thread to a warming fabric. The ocean, once present, becomes the great capacitor. It takes heat without complaint, spreads it by currents, and hands it back to the air in measured doses. A global fever would have driven the oceans off. A global chill would have locked them down. The record says neither tyranny prevailed. A narrow channel opened between the extremes, and water sailed it. Seafloor fabrics disobey simple predictions about a world that should have cooled as a quiet sphere. Pillow structures, frozen while lava inflated underwater, and chemical layers built from iron that dissolved and then fell as rust in pulses, imply not only a working ocean, but also cycling chemistry and redox states. That cycling needs vertical exchange and time. The implication cuts against a belief that the planet breathed only through volcanoes and impacts. It suggests circulation that is not just weather at the surface, but an exchange in stone and brine, with heat supplied from below and tempered by water moving in loops through rock. The field that shields the sky from star wind complicates the surprise. Signs of early magnetism are etched into ancient lavas and sediments, a faint record of directions that were frozen at cooling. A magnetic field in the deep past protects an atmosphere that would otherwise have thinned quickly, and with it protects the ocean that depends on pressure and air to remain present. Dynamo models expected a core still organizing itself, perhaps late to throw a shield. The rock record nudges those models to accept that the engine began earlier, or that the core cooled faster than a naive timeline guessed, or both. Protection and water and weather become a triangle that stabilizes the surface long enough for continents to draft their outlines. The mantle, by temperature, should have poured out ultramafic lavas across the board. Those lavas exist, their textures preserved like the frozen spray of a hot fountain. Komatiite belts tell of a deep source that boiled. Yet inside the same provinces, lighter magmas rose and pooled, delivers a paradox of opposites within a small geographical handshake. The shock is not that both were possible, but that both happened side by side, often enough to mark a pattern. The engine ran hot, yet it made cool products. It suggests a world already partitioned into domains where heat moved differently, where water reached deeper in some corridors than others, where crust sat thick enough here to survive and thin enough there to founder. Tectonics enters as a series of uncomfortable alternatives. If plates did not move, continents would be an accident that never repeats. If plates moved, something must have persuaded dense crust to sink before the planet grew an old, cold skin. Water can be that persuasion. It lurks in altered basalts, sneaks into minerals, and lowers the temperature at which rocks melt and weaken. A slab made heavier by age and hydration will choose descent if given a hinge. The hinge could be a rift that overreached. It could be an impact site where fractures reached the mantle and invited foundering. It could be a margin where spreading outran heat supply and allowed cooling to win. Every option violates an earlier simplicity, and every option feels like a breath of realism. Weathering rates jar expectations as well. On a hot planet, with fresh crust exposed and rain delivered in regimes rather than storms, chemical attack on rock should be fierce. That attack strips cations that build the ocean's salinity, builds clays that change the behavior of slopes, and buries carbon as carbonate minerals. The interaction of crust and ocean becomes a thermostat, because the more carbon the air holds, the faster rain acidifies, and the quicker it frees ions that end up as carbonate on seafloors. The earlier view preferred a planet governed by single processes, heat out and cooling in. The data paints a council chamber instead, feedbacks passing motions in meetings that run without adjournment. Sedimentary structures carry their own small rebellions. Ripple marks preserved in very old successions, graded beds laid down by turbidity currents, even crossbedding that implies steady winds over exposed flats. All argue for not only water and gravity at work, but for landscapes that survived long enough to store patterns, and for those patterns to be buried gently. A catastrophe model is poor at preserving subtlety. It leaves shatter and shock and glass. The archives display rhythm and repetition. That difference forces a revision in how to picture the Hadean and early Archean surface, not as a ruin that never healed, but as a workshop with long benches and tools put back in order between shifts. Time itself becomes suspect in its old pacing. The interval between crust formation and crust recycling looks shorter than comfort allowed. Crystals that measure ages also carry scars of dissolution and regrowth. Rocks that hold one metamorphic fabric can hide traces of an even earlier one beneath it. Episodes many imagined as singular appear instead as cycles, early and often. Continent making becomes less like a single upthrust and more like an apprenticeship of repeats, each round adding buoyancy, each round deepening roots, each round increasing the chance that a fragment will rise and float long enough to greet the sea with a stable face. The shock completes itself when the last simple picture is set aside. The planet did not wait for permission to become complex. Water, rock, and heat found each other at conditions that betray neat timelines. Oceans arrived under a dim sun and did not vanish. Pale crust distilled from dark sources in a mantle still running a fever. A field rose in the core and threw a roof overhead in time to keep the air and the ocean from wandering away. Weathering ran fast enough to salt the sea, and slow enough to preserve the forms that explain its speed. Tectonics, in embryo or already a conversation of slabs, began to draft the first margins where continents would take their breath. He closes the ledger and writes a different preface. The early Earth did not defy physics. It used all of physics at once. The surprise lies in the simultaneity, in the way feedbacks braided into stability sooner than modest models guessed. Shock is the name for the moment when an idea yields to a better picture. In that moment, the birth of continents and oceans stops being a long epilogue and becomes the opening chapter, and the planet starts to look less like a stage set and more like a mind, complex enough to hold opposing motions, long enough to let them argue, and patient enough to make edges out of the argument. He turns to instruments that can hear what eyes cannot. A seismometer buried in quiet ground records the crawl of waves that have crossed the planet and returned with news of invisible shapes. From those tremors, mathematicians assemble images of roots beneath old continents, keels of cool, depleted mantle that hang like stone glaciers beneath cratons. Their thickness and chemistry speak of an event that forged them hot and early, then froze them into persistence. Diamonds raised by kimberlite pipes carry tiny prisons inside them where olivine and garnet still hold the trace of that ancient chill. A few crystals even trap ringwoodite, rich in hydroxyl, a mineral that testifies to deep water caught in the mantle like breath held for geologic ages. The planet did not only learn the surface language of oceans, it nested water within its interior and let that reserve temper the rise and fall of heat. He watches a beam of electrons sweep across thin slices of rock. Under the microscope, inclusions inside zircon grains glow with meaning. Some carry quartz and feldspar in combinations that match crust formed from remelted basalt. Others hold mineral pairs that behave as thermometers and barometers. Their calibrations yield pressures that demand growth at depth and temperatures lower than the fever of ultramafic flows. The measurements converge on a portrait. Pale magmas assembled within thicker crust than a simple basaltic lid could supply, then rose and crystallized in a world already practicing vertical organization. Another lab reads hafnium in zircon like a biography of sources. Lutetium and hafnium decay together at a pace that allows model ages for the separation of crust from mantle. Grains that are 4 billion years old carry epsilon values that point to a mantle source already depleted by earlier melting. A paradox resolved if even older crust formed and recycled before those grains were born. Oxygen in the same crystals carries heavy ratios consistent with interaction between magma and water-altered rock. When plotted together, hafnium and oxygen draw lines that cannot be faked by contamination alone. They demand a system that mixed mantle and reworked crust, a rhythm of extraction and return that began long before continents became large. He stands by a furnace where olivine melts are held at temperatures that rival small stars. Experimental petrology pushes rock to conditions that match those recorded by komatiites. The melts reveal viscosities and densities that clarify how fast they could flow and how likely they were to erode channels into the crust. From their magnesium content and the chemistry of spinifex textures, researchers calculate mantle potential temperatures. The results line up with a world hotter by hundreds of degrees than any that followed, yet the same calibrations show how quickly heat could be shed if water lowered melting points and allowed vigorous recycling. The thick keels inferred from seismic images look less improbable when the experiments reveal efficient ways to strip heat by dragging wet basalt downward and melting it into paler crust. He visits a mass spectrometer tuned to delicacies of chromium, nickel, and vanadium. Ratios in ancient basalts speak softly about the redox state of their source. The trend moves toward more oxidized conditions with time, a shift that changes how iron behaves and whether sulfur prefers to ride as sulfide or sulfate. That choice affects how metals concentrate, how magmas rise, and how volatiles partition between melt and gas. The redox journey couples to the history of air and water, as weathering pumped more oxidized species into the ocean and as hydrogen escaped to space. The mantle's inputs had to meet a surface that no longer reacted like a young anoxic world. This mutual adjustment is visible in trace elements that refuse to lie, their ratios preserved even after metamorphism. He unrolls maps where gravity data and magnetic fields reveal scars hidden under younger cover. Anomalies trace old sutures where buoyant blocks docked, kinked, and locked. Tomography extends those lines downward to show cold tongues that once were slabs and now rest as ghosts in the transition zone. Mineral physics predicts their buoyancy at those depths, and seismic velocities confirm they are still colder than their surroundings. The planet keeps a memory of subduction in 3 dimensions, and that memory holds ages that reach into times when textbooks once claimed such behavior was impossible. A different series of records arrives from the surface of ancient sediments. Detrital mineral suites found in river deposits change through time in ways that track the topography and composition of the lands that fed them. Early successions are rich in unstable mafic grains that weather quickly. Younger ones collect more quartz and feldspar, a trend that speaks of rising continental crust and longer pathways from mountain to sea. Zircon is faithful through all of it. Its age distributions stack into peaks that mark episodes of crustal growth. Some peaks align across separate continents that were far apart in later reconstructions. Their alignment is a hint that cycles of assembly and breakup began earlier than cautious models propose. He considers noble gases, those aloof witnesses that seldom join chemical stories. Xenon isotopes in ancient rocks and in the atmosphere carry a fractionation that requires early escape to space and early trapping in minerals. Iodine and plutonium decay to xenon in ways that allow clocks to be set for when the atmosphere became a permanent resident. Those clocks point to a time window that overlaps with the ages recorded by the oldest zircons. An atmosphere that learned to hold steady pressure and composition arrived early enough to support a stable ocean. The gases insist that the roof was on the house when the first floor plans for continents were drawn. In a gloved hand, a small piece of banded iron reflects light in layers that alternate metallic grey with rusty red. The chemistry encodes pulses of dissolved iron delivered to seawater and the moments when conditions forced that iron to fall as minerals. The alternation demands time, currents, and a warehouse of iron in hydrothermal sources. It also demands a sink. As carbon dioxide combined with cations to make carbonates on the seafloor, and as silica precipitated to armor vent chimneys, the ocean learned to buffer itself. The steadying of chemistry supports climate that does not run to extremes. The bands are less a painting than a cardiogram of a sea that had learned a pulse and kept it. He moves from stones to machines that mimic mantle lifetimes in silicone tanks and supercomputer grids. Numerical models seeded with realistic rheologies and water-dependent weakening show that a stagnant lid can break if impacts fracture it deeply, if plumes cluster and thin it regionally, or if spreading outruns heat supply so the plate cools, thickens, and sinks at its margins. In these explorations, the key variable is water. With hydration, yield strength falls. With falling strength, the first descent accelerates. The model outputs generate trench-like features, arc magmatism, and the extraction of TTG magmas from hydrated basalt sources. When the models are tuned to the thermal budgets implied by komatiites and zircon thermometry, the patterns resemble the sutures and keels imaged by seismology. He stands at a shoreline cut into ancient gneiss that still shows the ghost of former mountains. Wave-polished pavements expose cross-cutting dikes and metamorphic fabrics that overprint older ones. Field relations here perform like a theatre of time. A pale Pluton intrudes a darker host. A mafic dike slices the Pluton. A later shear smears both into stripes. This order allows sequences to be established without a single instrument. When radiometric ages are hung on these relations, a ladder appears where processes that usually demand long cycles sometimes occurred in quick succession. Uplift, erosion, deposition, burial, melting, and rise, all within windows counted in tens of millions of years rather than hundreds. Rapid cycling accelerates crustal distillation and the building of buoyant roots. He reads clay minerals like weather reports fossilized in stone. Smectite gives way to illite in successions that speak of burial and temperature. Kaolinite blooms where rain and warmth persist. Chlorite grows in cooler, wetter regimes or as a metamorphic echo. Their patterns link to climate proxies in carbonates and to the direction of ancient currents recorded by ripples and crossbeds. Together they reconstruct basins that filled and spilled into seas that already understood circulation. The coastlines that fed those basins appear and vanish in the record, but their fingerprints remain in grains that remember how they were moved. He listens to a final set of testimonies from the deep, told by osmium in ancient sulfides. The ratio of radiogenic to unradiogenic osmium in marine sediments tracks the relative input from mantle sources and from weathered continental crust. The curve bends toward continental signatures earlier than expected, implying that widespread land with durable roots shed metals into the ocean during storms and normal days alike. The sea responded with shifts in its trace metal inventory that altered how quickly vents could build chimneys and how fast organic chemistry could proceed near them. The world of rock and the world of water closed ranks and began to act as one system. The data assemble into a picture that is less a portrait and more a moving film. Keels beneath continents, anchor plates, hafnium and oxygen in zircon record, early recycling. Mantle temperatures read from komatiites explain vigor and the need for help from water to start descent. Noble gases date the roof overhead. Banding in iron speaks to rhythm in the sea. Models show how weakness grows from hydration until a slab commits to the deep. Field relations demonstrate speed and repetition. Osmium tells the ocean who was feeding it. Every line converges on a single insight. The birth of continents and oceans was not a sequence of isolated acts. It was a network of feedbacks entering resonance, a choreography in which evidence can still be seen in crystals, waves, and the quiet chill of the mantle's oldest shadows. He lifts one thread and finds a knot. Every measurement that promised clarity tangles with another that refuses to agree. Zircon ages speak of cool magmas rising early, but many rocks that might have wrapped those magmas have vanished, leaving only crystals carried downstream like letters cut from a burned book. The gap is troubling. If continents rose, where are their shorelines? If oceans sprawled, where are the thick piles of sand and mud that oceans love to keep? A planet this active is a planet that recycles. Subduction can erase whole provinces cleanly. Impacts can shatter and melt a basin beyond recognition. The record resembles a palimpsest where old words ghost through new ink, and the reader never knows which sentence sits on top. Thermal physics pushes the knot tighter. Heat flow should have been so high that any plate trying to dive would soften and tear before it could slide deep. Cold, strong lithosphere makes descent efficient, and there was little cold strength to go around. Yet geochemical signatures point to rocks made from basalt that met water and then melted, a pattern that modern arcs repeat. Models respond with compromises. Descent could begin in short segments. Slabs could break off. Younger plates could sink only a little and still generate the right magmas. Each concession keeps the possibility alive, but each adds moving parts that multiply uncertainty. The onset of recycling becomes not a switch, but a patchwork, a mosaic of local experiments in failure and flow. Climate deepens the puzzle with a mirror of contradictions. Under a dim star, rain should have frozen at high latitudes and marched toward the equator. Greenhouse bouquets of gases had to offset that deficit. Carbon dioxide, methane, perhaps hydrogen in the upper air, all tried on the work of warming. But the same oceans that help keep temperature steady also bury carbon by weathering and carbonate formation. The thermostat can make a world too stable. If it damps fluctuations quickly, how did the sea manage radical chemistry, swings that built bands of iron in thick successions? If it did not, why did the water not bolt toward ice or steam? The balance appears as a tightrope stretched across deep time, and the footprints on it are light enough to doubt the rope was there at all. Water's origin interrupts with its own questions. Hydrogen to deuterium ratios in the sea say one thing, trapped volatiles in mantle minerals hint at another. Comets carry mixtures that do not perfectly match. Carbonaceous meteorites carry closer signatures, but not every box is checked. If water arrived both from inside and from beyond, in what proportions? If much of it came from the mantle, when did the interior learn to exhale enough to fill basins? If much of it came in as ice on wandering stones, how did the atmosphere survive the heat of repeated impact? Each path is plausible alone. Together they draw a blended story that resists precise percentages. And those percentages matter because they change the timing of oceans and the vigor of deep recycling. The moon adds a quiet complication. With its close gravity, tides ran high and frequent. The constant kneading of the crust by ocean bulges could have weakened margins and coaxed fractures toward foundering, an ally to the birth of slabs. The same tides would have pumped estuaries and shelves, stirring chemical gradients that accelerate weathering and sediment delivery. But a stronger tide also increases mixing in the ocean and robs it of stratification. Many chemical archives require layers in the sea that rarely touch. Did tides help continents rise by softening their edges or hinder the ocean from drawing clean chemical lines between deep and shallow? The answer may be both, which is not the comfort anyone hopes for in a mystery. Impacts refuse to take a place at the back of the line. The late bombardment rains stone and metal in diminishing bursts that could sterilize wide regions, flash boil shallow seas, and blanket continents in melt sheets. Each blast is a chance to reset clocks. Each basin is a trap for water that then steams away. Yet isotopic records demand oceans that lasted. Did impact seasons come as intervals separated by long, quiet centuries? Did thick clouds born of ejecta keep the surface warm and damp, turning catastrophe into a greenhouse? Simulations produce many worlds from the same inputs, and none of them is entirely wrong. The difference lies in initial conditions that cannot be sampled, only inferred. He tries another angle and finds the deep mantle holding secrets in reserve. Seismic tomography sees regions that move sound sluggishly, reservoirs that hint at primitive composition or at vast piles of subducted crust. If piles exist, then slabs reach depth. If regions are primitive, they survived mixing. The interior may be a chimera, part untouched from early differentiation, part compost of crust fed back in ribbons. Either vision changes the chemistry of magmas that feed early land. Either vision alters the budget of heat, because different materials store and release energy at different rates. The stones at the surface know the outcome but not the recipe. Bathymetry turns slippery in his hands. The height of early continents depends not only on rock type, but on how thick and cool their roots became, and how hot the mantle pressed against them. Ocean depth depends on the age and density of the floor, and that age is a function of spreading speed that itself responds to heat. A hotter mantle builds higher ridges and shallower basins. Shallow basins change the volume of water needed to drown land. The difference between a blue planet with scattered islands and a world with broad continental platforms could be a few hundred meters of average basin depth, a measure that cannot be read directly from any surviving page. Sediments complicate the margin between answers. Sand and mud volumes speak to relief and climate, but ancient piles are small where they ought to be large. Either coasts did not last where they formed, or currents swept the record into deep basins now recycled, or early landscapes were low and smooth, the relief diluted by hot, weak crust that could not hold mountains long. Each alternative fits a piece of the map and fails another. The very strength of the mystery is that it does not yield to a single kind of evidence. It demands patience with partial stories and comfort with opposing truths that meet only at their edges. Magnetism writes in a script easy to smudge. Remnant directions in very old rocks carry the memory of a field, but heat and metamorphism can reset those directions without obvious scars. When the magnetization is faithful, it can fix latitude, reveal wonder of the poles, and sketch plate motions in broad arcs. When it is not, it draws illusions that pass peer review and fate later readers to rewrite atlases. Some signatures suggest a field as strong as later ages. Others imply something weaker or more erratic. If the field flickered, atmospheric escape rates changed with it, and the ocean's volume became a variable whose curve is hard to sketch without guessing. He lets the contradictions stand for a moment and notices that each one sharpens the central question rather than blurring it. Early continents needed buoyant crust and strong roots, yet heat resisted both. Early oceans needed stable basins and a protective roof, yet impacts and escape threatened both. The data split the difference in ways that look suspiciously like feedback at work. Water weakened rock enough for recycling to begin locally. Recycling fed pale magmas that rode high and taught the coast what it felt like to persist. The ocean then buffered heat and chemistry, giving climate and crust the room to specialize. Each victory introduced a new vulnerability. Raise land, and you increase erosion. Deepen basins, and you change circulation. Strengthen the field, and you lower escape, altering atmospheric composition and the tools available for warming. Escalation hides in the details of time. Growth of continental volume appears in pulses, then pauses, then pulses again. Each growth spurt aligns with chemical shifts in the ocean and with episodes of more mafic or more felsic volcanism. The cycles refuse to fall into a single rhythm. Some look driven by the interior's tempo. Others seem to answer climate and weathering that modulated CO2 and altered mantle melting by changing pressure distribution through water load on the seafloor. The moving parts interlock, but the gears are not fixed. Their teeth slip, engage again, and slip once more. The result is motion that repeats without repeating itself. He stands at the edge of the paradox and sees why the question deepens the more it is asked. Birth is not an instant. It is a regime change that requires many thresholds to be crossed together. Crust must lighten, water must settle, air must shield. Heat must distribute. Gravity must find patterns that allow stress to concentrate and then release. When any one of these runs ahead, the others must catch up or pull it back. The traces left by the catching up are the anomalies researchers fight about. They are not noise. They are the useful scars of a system achieving an identity that can last. The knot remains, but its strands are visible now. Conflicting clocks, half-erased coastlines, hot lavas beside cool granites, a dim star above a world of open water, tides hammering and helping, impacts erasing and enabling, deep reservoirs mixing and refusing to mix, basins shallow and deep by turns, fields strong and fickle. The mystery does not permit a single line drawn from start to finish. It requires a braid. Each thread darkens where the others brighten. Each thread brightens where the others darken. He recognizes the right kind of difficulty. Not confusion, but complexity. Not failure of method, but success of a planet that learned to use many tools at once and left us with the challenge of teasing each tool's mark from the stone. He gathers the models like constellations and lets them speak in turn. One draws a picture of a planet wearing a stagnant lid, a shell that shrugs but will not slide. Beneath that armor, plumes rise from deep heat, punch through, and spread like umbrellas that rain fire. In this vision, continents are the residue left when repeated plumes distill lighter ingredients upward. Each umbrella cools as it spreads, each returns heat to the sky, and an archipelago of buoyant crust accumulates, not by collision, but by distillation. The shorelines that follow are the outlines of rafts that learn to float by being boiled many times instead of once. Another sketch begins where the first ends. The lid is not invincible. Thermal cracks grow long, impacts carve weaknesses, water infiltrates the mantle's upper stories, and grain boundaries in olivine slip more easily when damp. Rheology bends towards softness in zones of damage. Slabs do not start with a parade into the deep. They begin with short experiments in falling. Drips detach from the base of thickened crust and ride down like slow tears. Foundering piles tug new tears from their edges. At the surface, each failure leaves a basin and a belt of hotter rock that becomes a line of volcanoes. Over time, the drips organize into arcs, arcs into chains, and chains into something that deserves the word plate. A third proposal climbs up from the aftermath of a magma ocean. When the last global melt cooled, crystals settled not quietly but in a sequence that left density traps and chemical layers. Overturns followed. Heavy cumulates sank. Light residues rose. The mantle learned columns and corridors. Where buoyant material gathered, it fostered early domes of pale magma. Where dense cumulates pooled, they invited sinking of surface slabs when the chance came. Continents in this tale are the survivors of a late sorting, rafts that escaped because their roots had been scoured of iron and water had stiffened them with serpentinized margins that resisted heat. A fourth idea gives the moon more agency than a polite satellite usually claims. With the moon close and the day short, tides flexed the crust without rest. The flexure heated fault zones at the very margins where ocean weight changed twice daily. The heating was small, but it was constant, and the kneading promoted mineral reactions that weaken rock. Once a section of lithosphere met water along deep fractures, hydration crept downward, lowering melting temperatures and easing the first descents. Tides were a metronome that counted out the beats needed to turn bending into breaking and breaking into motion that did not forget to continue. He lets a plume school argue with a slab school and does not award a winner. In plume first worlds, continents are the paler caps of broad swells, their roots depleted by melting, their faces armoured by granitoid intrusions that arrived gradually. In slab first worlds, continents are the offspring of basalt that sank after hydration and returned as paler melts, a faster, more surgical invention. Both frames claim the tonalite and granodiorite that sit at the heart of ancient block. The real answer may be a braid. Plumes gather heat and deliver fertile basalt. Slabs carry that basalt down, add water, and melt it into buoyant magmas. The same region can play both roles across a few tens of millions of years, and leave a root that is chemically distinct and geometrically stubborn. He considers a heat pipe planet as an ancestor, a surface ruled by volcanoes that reach from deep sources to open sky, so often that the lithosphere behaves like a radiator. If eruptions were frequent enough, they could carry heat outward efficiently without requiring plates. The top would cool, thicken, and fracture, yet the fractures would be healed repeatedly by fresh flows. The transition from pipe to plate would occur when hydration and damage tilted the balance, allowing the fractures to stay open long enough to become faults that slid sideways or down. In this picture, the first continents are simply the patches of crust that experienced more distillation than their neighbors and then escaped the next round of burial. Delamination offers another route. If basaltic plateaus grew thick above warm mantle, their bases would metamorphose to eclogite, a denser rock that wishes for depth. The heavy roots would peel away and plunge, while the buoyant tops would bob upward. The bobbing would stretch the crust, invite pale melts to rise, and create islands of low-density rock with space to collect sediments and rain. Each delamination would be a small secular miracle, removing weight from the underside without a trench, making room for softer magmas to curve against the new hollows and consolidate a continental seed. Grain damage mechanics speak in the quiet language of texture. In olivine, grain size controls strength. Deformation reduces grain size, reduced grain size localizes deformation further, and a feedback loop opens. Add water, and the feedback strengthens. At first, the planet could have deformed broadly, but zones of localization would sharpen with time, creating narrow bands where the lid could break. Those bands are the ancestors of faults and plate boundaries. Where they crossed, triple junctions of motion would pin geometry in place. Continents would grow preferentially where these junctions focused pale magmatism and sheltered buoyant blocks from being pulled apart. He examines the ocean itself as an active theorist rather than an audience. Early water carried high concentrations of dissolved minerals and high heat. Its presence altered the density of the shallow mantle by driving serpentinization along fractures. Serpentine is lighter and weaker than peridotite, and it carries water downward. In zones where plates tried to sink, serpentinized channels would act as conveyor belts for both mass and weakness. If those channels formed early, the ocean would have been stitching its own future trenches by choosing where to thread water into stone. The map of first edges would have been written as much by currents and fractures feeding each other as by deep plumes choosing their ground. He opens the door to impacts as architects rather than vandals. A large strike can excavate a basin, fill it with melt, fracture the crust to the mantle, and seed a long-lived weakness in the lid. As the basin cools, dense melt ponds at depth and invites foundering of the floor. Water rushes in from the rim, circulates, and hydrates the newly broken corridor. In the next few million years, that corridor becomes a place where descent is possible. An arc rises nearby, feeding pale magmas that float. Where two impact corridors intersect, the chance of sustained recycling and crustal growth doubles. The scars of violence become the keystones of order. Mantle reservoirs join the chorus with two basso voices that may be older than continents themselves. Broad regions in the deep mantle appear to be compositionally distinct, perhaps the survivors of early differentiation or piles of ancient slabs. If such provinces focus plumes, they could impose a pattern on where buoyant crust grows. Continents might then prefer positions above long-lived upwellings, a geographic bias that survives through cycles of assembly and separation. True polar wander adds a slow dance to the script, reorienting the shell above the interior so that continents drift not only by plate motion, but by the planet's choice to realign mass relative to spin. He lets climate contribute hypotheses. Weathering of rising land can draw down carbon dioxide and cool the surface. Cooling thickens the lithosphere, strengthens slabs, and deepens basins. Deepened basins lower sea level relative to land, expose shelves, and increase weathering further. The thermostat that keeps water liquid becomes a knob that tunes plate vigor. Conversely, vigorous spreading raises, ridges, shallows the ocean basins, drowns land, reduces weathering, and lets carbon dioxide accumulate. The sea and the crust conspire to pace each other, and continents are both the engine and the record of that pacing. Speculation reaches into biology without letting it take center stage too early. Even before oxygen rose, microbial films could have colonized warm shorelines and hydrothermal mounds. Their mats trap sediment, promote mineral precipitation, and change the chemistry of local water. On a coast where every grain matters, that small encouragement could stabilize bars and shoals. Stabilized shoals break waves farther from rock, lessening cliff erosion and allowing low-relief platforms to expand. It is not that life built continents, but that life may have offered a few early braces in a structure still testing its bolts. He asks the ocean to explain its own depth. The volume of water at the surface is not fixed solely by delivery. Regassing drags ocean water into the mantle through minerals, while degassing at ridges and arcs returns it. The balance sets sea level in a first-order way, once basins are large. If early subduction, however patchy, pumped water inward faster than ridges could release it, sea level could have fallen even as basins were shallow from heat. A slightly lower ocean would expose pale rock and give weathering more agency, a feedback that then changes melting in the mantle by altering surface pressure. Continents would therefore be indirect consequences of a dialogue between water budget and heat budget. Future tests are already written into stones waiting their turn. Old cratonic roots retain seismic anisotropy that remembers the direction of flow during their birth. Nanoscale defects in zircon may store clues to the water content of the magma that fed them. Noble gases trapped in ancient inclusions stand ready to refine the time when the atmosphere reached a pressure that could protect oceans without fail. Piles of subducted crust deep in the mantle may reveal themselves by neutrino tomography and oddities in the way seismic waves split. Each promised measurement offers a way to award weight to one constellation of models over another. He closes the circle with a simple image. A young world possessed many levers: plumes, drips, delamination, tides, impacts, hydration, grain damage, overturns, regassing, degassing, weathering, and the quiet persistence of water itself. None of these by itself explains what a coastline is. Together they carve the first secure shapes of land and teach the sea where to rest. Theories are not competing flags in this landscape. They are tools laid on a bench, each meant for a particular cut, each dull in the wrong hand, each sharp when applied to the right grain. Continents and oceans arise when the workshop learns to use all of them in sequence, when the feedback is tuned just far enough from silence to sing, and when the planet breathes with a rhythm that keeps edges alive. He walks into a hall of instruments that trade patience for vision. Along one wall, spools of glass fiber wait to be married to the earth. When light is sent through these cables and scattered by tiny imperfections, the strand becomes an ear. Distributed acoustic sensing turns buried fiber into thousands of seismometers, hearing traffic, thunder, surf, and the murmurs of faults at depth. Where these fibers trace shorelines and cross shelves, they catch the whisper of microquakes that map hidden sutures. The coast answers with signatures that reveal whether plates are locked or sliding, whether roots are cold or warm, whether the edge is gathering stress or letting it flow away. Offshore, robots drift like quiet thoughts. Argo floats sink, measure, and rise, returning profiles of temperature, salinity, and velocity from abyss to sunlit skin. Deep variants push farther, sampling waters that rarely feel wind. A fleet of gliders writes long transects along continental margins, where newborn crust exhales and old crust inhales. The data feed models that test how heat and salt travel around the edges of land. Where the numbers require extra mixing, tide and topography must be conspiring. Where stratification persists, the sea is protecting chemistry in layers. These maps of motion are not ornaments. They are boundary conditions for any theory about how coasts teach climate and climate answers with storms. A ship lowers a string of ocean bottom seismometers onto a pattern chosen by curiosity. Weeks later, the instruments return with waveforms etched by distant earthquakes. Ambient noise between stations is cross-correlated into images of shear speed beneath the margin. The lithosphere and the mantle appear as volumes, not lines. A step that marks the base of the plate comes into focus. Under some shelves it lies shallow and sharp. Under others, it fades, as if the plate is frayed. The difference matters because a frayed base invites drips and small descents that can draw pale magmas toward the surface without the ceremony of a trench. On deck, a rig hoists a core barrel speckled with chalk. Sediment taken from beneath the seafloor reveals magnetic reversals that bracket time, microfossils that bracket environment, and mineral cements that bracket chemistry. In certain horizons, volcanic ash shards rest between quiet mud. The shards carry glassy signatures of their source. Trace elements and isotopes guide them back to arcs and plumes. By counting these layers and matching them to shore rocks inland, the tempo of erosion and the pace of crustal growth can be estimated with enough precision to challenge or comfort a model. Airborne surveys paint cratons with invisible colors. Magnetotelluric arrays read the planet's electric field as it changes with solar storms and lightning. Conductivity maps emerge that show serpentinized channels like rivers frozen in stone, belts where fluids travel, and keels so dry and pure they refuse current with aristocratic disdain. Where the maps cut to the coast, they show where the water has threaded far beneath arcs, whether slabs feed fluids into the mantle wedge, whether the first recipe for pale magmas is still being cooked at depth. Gravity data flown along the same lines fill gaps with gentle, long-wavelength clues about density. Where gravity lows sit under strong resistors, buoyant roots announce themselves without breaking the surface. In a different building, a diamond cell the size of a teacup holds a fleck of peridotite between anvils cut from stars. A laser warms the speck, while X-rays from a synchrotron probe its structure. At pressures and temperatures that belong to the deep mantle, olivine transforms, water hides in new sites, and melting points slip downward. The results are numbers without romance. Yet they decide whether serpentine survives to carry water into the transition zone, whether drips detach cleanly, whether delamination can peel a root. The same beam scans tiny inclusions in diamonds rescued from pipes that once rose like rockets. The inclusions confess their phases and their fluids, their redox states and their salt. A story emerges in which oceans truly enter the interior and return slowly as breath through arcs. Another lab cleans a room until dust has nowhere to hide. There, an atom probe takes a zircon needle and strips it atom by atom with electric fields. The flight paths of ions reveal concentrations at nanometer scales. Within the crystal, a spear of altered lattice betrays a fluid that passed 1 billion years after the grain was born. Uranium and lead here are unshocked, they're disturbed, and the pattern ties a datescape to events that reheated the crust or carried water through it. Modest maps like these decide whether a zircon's clock is honest, and whether the heavy oxygen it carries truly comes from cool weathering or was painted on later during burial. Over a bench, tiny crystals of apatite burn with invisible trails when bombarded. Fission tracks count the time since they cooled below closure temperature. Helium, trapped in the same mineral by alpha decay, escapes at rates that turn into cooling histories when measured against size and shape. Thermochronology stacks these data into curves of uplift and erosion. When plotted along a transect from mountain to shore, they show pulses of exhumation and pauses of burial that match changes in sea level and climate. If uplift surges when a root peels away, a delamination event earns a date. If burial dominates while the ocean shoals, spreading must have raised ridges and shallowed basins. Satellites join with patience from above. Interferometric radar compares the phase of microwaves between passes and reveals millimeters of motion over months. Subduction zones breathe in cycles that this technique can see. Locked patches swell. Unlocked patches lead. Gravity satellites measure changes in mass that betray whether aquifers are draining or mountain snowpacks storing water, because the weight of water loads the crust and leans on faults. Global positioning arrays record plate motions with the punctuality of clocks. Some lines shorten, some lengthen, and triangles of motion sketch the stress that molds coastlines and decides where edges persist. Clumped isotopes set thermometers in carbonates by counting how often heavy atoms bond to each other instead of to light partners. Triple oxygen isotopes separate temperature from water source. Iron and chromium isotopes score redox more subtly than bulk ratios ever did. Molybdenum in shales whispers about the breathability of deep water. These tracers connect shelves to oceans to air and back again. At the scale of a single pore, micro X-ray absorption near edge structure reads the valence of iron in a grain and the coordination of sulfur in a pyrite. With such details, a core section becomes a chorus line of tiny witnesses. On land, ophiolites lie like books tossed open by tectonics, pages of oceanic crust and mantle brought to air. Geologists read cumulate layers in ancient magma chambers, pillow lavas frozen mid-inflation, and sheeted dike complexes that once fed ridges. They measure orientations, date intrusions, and catch fluids still trapped in veins. In some suites, high-pressure minerals imply that part of the package rode down and then back up. Those minerals fix pressures and temperatures that no present ocean floor will ever confess before subduction takes it. When the ages of these rocks match pulses in detrital zircon, a link is forged between oceanic processes and continental growth. Analog tanks bring humility by showing how simple physics invents complexity without permission. In a tray of syrup and sand, with a background flow driven by a heater and cooler, a lid of wax fractures into rafts that raft again, collide, and founder along drips of cold. Salt water added to the base supplies, density contrasts that create delamination in miniature. Dye outlines streams that resemble plumes, but their behavior depends more on viscosity and boundary slip than on the desire of heat to rise. The lesson is not that the tank is the world. It is that the world obeys rules that can be rehearsed safely, so that instincts are trained before numbers are trusted. Computers watch all of this and learn to speak without boasting. Inversions assimilate seismic, gravity, and electromagnetic data into joint models where one constraint rescues another from ambiguity. Ensemble simulations run with slightly different initial conditions map the sensitivity of outcomes. Bayesian frameworks make prior beliefs visible so that they can be confessed and adjusted. Patterns from satellite time series help identify when a coastal arc is preparing a new episode of intrusive growth or when a margin is relaxing into quiescence. The outputs do not decide between theories by vote. They weigh them in a balance where each new measurement shifts the pointer slightly. He ends the tour where shore meets lab. A wave gauge buried in sand tracks run up and retreat, while a LiDAR scans the beach face in passing planes. Grain size distributions update in real time as cameras classify textures with trained networks. Storms arrive and leave their signatures as maps. The next tide modifies them. When compared with the mineral and chemical fingerprints of the feeding rivers and the lithology of headlands, the shapes reveal how coasts sought material inherited from deeper stories. In these fine scales, the argument about continents and oceans becomes personal. Each bar and terrace is a decision made from ingredients supplied by mantle and sky. Tools turn curiosity into test. Fibers hear stress. Floats hear heat. Seismology paints roots. Drills collect time as dust and mud. Beams coerces truth from atoms. Satellites watch the breath of plates and the weight of water. Tanks imitate. Codes negotiate. Through this choreography, hypotheses lose their softness and gain edges. Where the picture fails, another instrument is built. Where the picture holds, the confidence to imagine increases. The birth of continents and oceans remains a mystery, but it is a shrinking one, eroded grain by measured grain, lifted into view by coherent noise, and assembled into maps that make the planet's first margins feel less like legend and more like work still visible in the present tense. He stands on rock that does not flinch. The outcrop rises from scrub and wind like a knuckle of time, banded with pale veins and darker hosts, crossed by dikes that froze mid-flight. A hammer would ring here with a tone closer to metal than to earth. Beneath his boots extends a body that reaches deep, a keel of dry, depleted mantle welded to crust thick enough to carry memory without bending. This assembly has met heat and pressure and decided to keep its shape. It is a promise written in peridotite and quartz, a vow against easy change. The keel is not decoration. It is chemistry turned into structure. Mantle beneath old centers has been melted so many times that iron and basaltic ingredients are gone in part, leaving residues enriched in magnesium and refractory minerals. That residue is lighter at given temperatures than the fertile mantle around it. Buoyancy follows. Once cooled, the keel hangs like a stiff iceberg in the hotter, softer asthenosphere. It resists reheating because it is dry. Water that weakens and lowers melting points is sparse here, locked away in tiny defects or absent altogether. The result is a lid within a lid, a plate within a plate, a foundation that does not readily surrender to the convecting world below. At the surface, these provinces wear two masks. Where erosion has stripped their blankets, shields expose crystalline roots polished by ice and rain into low, shining domes. Where sediments have gathered, platforms hide the same strength under flat layers of sandstone, limestone, and shale. The difference is only a costume. The stiffness beneath governs both. Rivers on such ground meander with patience. Basins subside slowly, wide sources that fill in cycles and seldom tip into deep trenches. When seas invade, they spread as shallow empiric waters that glitter under long summer light and retreat without leaving scarps. The geometry of living and dead things on these shelves writes quiet pages, a contrast to the jagged annals saved along active margins. In the belts that lace these interiors, greenstones lie beside tonalites, the pairings of volcanic flow and pale Pluton. Their folds and faults froze when the region stopped learning how to change and began to commit to form. The fabrics reveal an apprenticeship. Basalts once draped the surface, altered, buried, and metamorphosed to greenschist and amphibolite. Pale magmas rose through them and crystallized as granitoids. Later intrusions arrived as dikes that cut the older bodies cleanly, and later deformations smeared some of those cuts into ribbons. Then the movement slowed, then ceased. What remained is a palimpsest where the last script was written with a heavy hand and the page closed before another author could begin. Diamonds ascend through these keels like notes from a lower register, carried in volatile, rich magmas that shoot from depth faster than any normal melt can travel. Their crystals trap tiny worlds. Some hold peridotitic inclusions born in dry, depleted mantle. Others cradle eclogitic fragments that remember basalt turned dense at pressure. A few carry minerals that only exist when water has found a way to hide in high-pressure lattices. The mix proves that the keel has touched many stories. It has received, it has given back, and it has remained itself. These gems are not luxury here. They are thermometers and clocks, barometers and passports stamped at depths that never meet light. Seismic waves cross this architecture with attitudes it forces upon them. In some directions they speed, in others they lag. Anisotropy records the grain of ancient flow, the alignment of crystals when the root was still hot enough to move as a solid under stress. Fast axes point along fabrics that predate any recent mountain belt. Sharp jumps in velocity mark, where the stiff lithosphere gives way to softer mantle. Under certain cratons that jump is crisp and deep. Under others, it is rugged, as if tongues of the surrounding mantle have gnawed at the keel but failed to undo it. The picture is not symmetrical because history never is. Even endurance has a texture. Heat tries. Mantle plumes rise from below, their heads spreading and lifting the surface by a few 100 meters to 1,000. Flood basalts spill, paint black plateaus over old floors, and test the root with warmth and weight. Delamination threatens where lower crust transforms to denser assemblages. But in these old hearts that transformation often stalled long ago. The base refuses to peel. The plume exhausts itself, the plate cools, the basalt weathers, and the elevation settles back. The keel has noticed the visit, recorded it as a chemical overprint or a modest tilt, and moved on without surrender. This refusal is why continents hold their outlines long enough to develop identities and stories tied to place. Winds and water respond to this persistence. Stable interiors invite large lakes to linger, allow dune fields to migrate for ages, and host soils that mature slowly into profiles with deep horizons of iron and clay. When climate swings, the swing is recorded without the noise of rising chains. Fossil river courses cross later ones at angles testimony preserves. Empiric seas return in different epochs and spread familiar geometries of carbonate banks and evaporite flats. Life uses the stage. first with microbial mats that trap sediment into stromatolitic mounds, later with shelly reefs that build walls, later still with rooted forests that trap water in their shade. None of these creates the keel. All of them are faithful to the trust the keel provides. Edges of these interiors tell a more dramatic tale. Rifting can open where stress finds old joints, and the break cuts into the platform with a tidy valley that lengthens into a gulf. Passive margins follow, with wide shelves that sink gently as the lithosphere cools away from the spreading center. Here, the old continental mantle reasserts itself as a buttress. The shelf can hold enormous piles of sediment without collapsing into trench. Delta plains build outward, submarine fans grow into aprons, and the history of rivers becomes the architecture of a margin that waits for the next call to change. The cry of a mountain belt far away sends flexural waves that pass as quiet subsidence or gentle uplift. Inside, the keel continues to carry weight like a veteran accustomed to marching. Under certain maps, there are basins shaped like petals, intracrotonic bowls, with margins defined not by faults, but by the timing of subsidence and flexure. They form when the plate outside the keel changes load, when ice caps push or retreat, when mantle flow presses or relents. The response within is modest, a few hundred meters at most, but long-lived. Sediments accumulate with fidelity to gravity and climate, evaporites in dry cycles, coals in wet ones, carbonates in warmth, shales in quiet, deeper water. These basins are memory palaces. They do not shout, they keep. The keel's chemistry is a ledger of choices made early. Depletion in elements that favor melt tells how thoroughly the mantle beneath was cooked. Low water contents tell how completely volatiles were extracted. High magnesium numbers in olivine point to residues that cannot easily be returned to fertile states. Trace element patterns in mantle xenoliths reverse engineer the menu of melts that once left. The language is subtle. Small peaks and troughs at specific masses betray ancient melting in the presence or absence of garnet, in the range of pressures that separate spinel fields from deeper stability. From such curves, a profile of the birth of the root is drawn. It is not a single episode. It is an accumulation of extractions, each one making the next extraction easier to resist. When continents later gather into supercontinents, these keels act as the bones around which the body closes. Sutures favor the flanks of the strong blocks. Origins grow where keels meet other keels at awkward angles, or where mobile belts wrap around them. Heat builds under the assembly, trapped beneath the blanket of thickened crust. Migmatites bloom, granites intrude, and high-grade belts record the bake. Yet at the center, the core remains comparatively cool. When the supercontinent breaks, rifts prefer the old scars. The keel moves into its next cycle with new edges, but with the same interior, an elder that outlives the empires it hosts. Economies notice what physics prepared. Ore bodies align with old structures where fluids have traveled again and again, changing chemistry until metals fall in abundance. Kimberlites carry diamonds to the near surface, along deeply rooted fractures that the keel preserves. Sedimentary basins over the platforms hold hydrocarbons where ancient seas stored sunlight in carbon and buried it under time. These resources are not the purpose of the structure, but they are its consequences, and their distribution maps the strength and weakness of the deep in ways a ruler once learned without understanding the lesson. A breeze moves over the outcrop, and heat lifts like a sigh. The rock underfoot is not unique, yet it is rare enough to matter more than novelty would suggest. Without such cause, the surface would be all margin and no memory. With them, the sea can trust a shoreline to be there after the next storm. Mountains can trust a buttress while they rise and while they fall. Rivers can build hierarchies of channels that last long enough for ecosystems to specialize. The keel is patience made solid. The continent above it is a translation of that patience into landscapes where time has enough room to try ideas and keep the best. He traces a breath across water that has learned to think in loops. Wind writes the first strokes. Sun warms the equator more than the poles. Air rises, air sinks, and the drag of that moving sky pushes the surface into broad streams. The planet turns beneath, and the Coriolis effect folds motion to the right in one hemisphere and to the left in the other. Gyres appear as spirals set inside basins, with western boundaries sharpened into swift rivers by the squeeze of rotation. On their eastern flanks, currents slide broad and slow. Between them lies a sea of gradients, sloping surfaces held in place by pressure that balances the tilt of water with the impatience of gravity. The ocean practices geometry until it becomes instinct. Beneath the wind lies a memory of salt and cold. Evaporation lifts water into the sky and leaves brine behind, a quiet alchemy that thickens subtropical seas. Far to the north and south, winter air steals heat and sea ice grows. When ice forms, it rejects salt, a brine that trickles downward like invisible rain. Surface water cools, grows heavy, and plunges. Plumes descend, fold into sheets that slide along the bottom, and begin journeys that will last centuries. In the north, these waters slip through passes and spill into the deep Atlantic. In the south, where ice girdles a continent and winds circle with few obstructions, dense sheets pour off shelves and feed a current that races around the world. The ocean now owns a second breath, driven not by wind but by weight, a thermohaline ambition that knits basins into a global conveyor. Mid-ocean ridges arch as seams where the interior exhales. Heat leaks, mantle melts, and new floor spreads outward. The ridge is not a line but a rough mountain chain, pierced by vents that fling metal-rich water into the sea. The fluids mix and cool, minerals fall as dark smoke, and chimneys grow. Their chemistry changes the ocean's inventory grain by grain, concentrating some elements on the slopes, sending others into slow suspension. Above the ridge, the water thins and warms, a lens that accelerates flow along its crest. At depth, rough topography breaks the march of deep currents into eddies that share energy like dancers exchanging partners. Even without wind, the ocean finds ways to stir itself. Internal waves snake along density boundaries, where light water rides above heavy. Tides from the moon and sun push the sea against ridges and continental slopes, and energy bleeds into the interior as oscillations that rise and break far from shore. These hidden breakers mix layers that would otherwise grow stratified and still. In the abyss, tiny swimmers and falling grains contribute to the roughness that makes turbulence grow. Over time, the mixing lifts heavy water upward and lets lighter water sink, closing the loops that deep plumes began. Without this quiet violence, the deep would stagnate and starve. With it, oxygen follows slow paths to the bottom, and nutrients free themselves from sediments to embark on long tours. Along coasts where winds blow parallel to shore, the Coriolis deflection pulls surface water away and upwelling answers. Cold, nutrient-rich water rises to light, feeds blooms, and sets food webs humming in narrow belts that look from space like brushstrokes of green. The opposite wind piles water against land and pushes surface layers downward. Downwelling carries oxygen to depth and resets parts of the water column that might otherwise grow sour. These coastal pumps are small in area but large in consequence. They transfer energy from wind into fertility, from sky into carbon, stored briefly in bodies and longer in shells. A chemist could follow this breath through cycles that interlock quietly. Carbon dissolves as gas and takes forms that depend on temperature and alkalinity. In warm water, it hides poorly. In cold, it hides well. When organisms build shells, they borrow carbonate and lock it in lattices that settle as snow. The deeper the fall, the more likely the snow will dissolve before reaching the floor, because pressure and temperature decide where carbonate prefers to remain solid. There is a depth below which shells surrender. As circulation changes, that compensation level wanders. When deep water arrives enriched in carbon, the level rises, starving the floor of sediment and changing the hardness of future rock. Silica follows its own custom, raining from diatoms and radiolarians and dissolving according to a different clock. The ocean manages both ledgers with a competence that is never absolute and always practical. At the surface, maps of heat show spirals of warm and cool that travel with eddies spun from major currents. These vortices trap water for months, shepherding plankton and larvae, ferrying salt and temperature, anomalies across basins. Some sink, taking their stamps with them. Others unwind against continental slopes and leak their contents into shelves. In the tropics and subtropics, disturbances in the atmospheric engine shift trade winds and tilt the balance of the Pacific. When the trades slacken, warm water sloshes east, the thermocline flattens, and rain patterns rewire. When the trades return with vigor, the warm pool retreats, the thermocline tilts, and the far west recovers its heat. The ocean is not a pond. It is a negotiator that can rearrange weather on the strength of its stored warmth and its habit of long memory. Seaways act as valves that control exchange. A narrow strait can throttle a deep current and force water to choose higher paths. When two basins connect or disconnect, circulation regimes shift. Through times when high southern latitudes carried forests, the Great Circumpolar Highway did not exist, and heat reached the pole more easily. When a continent completed a ring and a wind found a lane without walls, a current usurped the role of gatekeeper and wrapped the planet. In the north, when land rose to seal a corridor, a link between oceans closed and the conveyor reorganized. The pattern of gyres that move surface water and the pattern of plumes that move deep water both took new shapes as doors opened and shut. Salt budgets keep score at a slower pace. Rivers carry ions won from rock to the sea. Hydrothermal vents remove some and add others. Evaporation in subtropical basins makes brine that wanders as dense tongues. Precipitation and runoff in equatorial belts dilute and build fresh lenses. The gradients these processes create guide surface flow and set thresholds for deep formation. A warm period can push the ocean towards stratification, hiding nutrients below and starving the sunlit skin. A cold period can roughen the column and feed the surface richly. The shoreline feels these changes as altered storm tracks, as different river floods, as sea levels that seek new equilibrium with the temperature and density of the whole. Sound travels far in water that is layered by temperature and salt. There is a depth where refraction bends sound back toward itself, a channel that lets a call travel for thousands of kilometers. The same physics guides energy from storms into the deep, where it ricochets from slopes and seamounts, and returns to the surface as swells that remember weather no one saw. Over abyssal plains, slow currents shape ripples of sand and mud that migrate like dunes under a wind only instruments know. On those plains, nodules of manganese grow in millimeters per million years, a mineral frost that accretes from dilute solutions moved tirelessly by faint flows. Even the floor that seems still accumulates proof of motion. Edges steer the global breath. Continental shelves bend currents into jets, and canyons focus tides into internal bores that run like trains along density steps. Sills between basins muster waterfalls of cold water that tumble and mix. Capes throw lee eddies that shepherd larval fish, and seeds of algae into retention gyres where populations take hold. Ice sheets clamp circulation under their skirts and set brine factories along their margins. When shelf ice calves, fresh water caps nearby seas and slows sinking. When sea ice spreads, brine deepens the reach of winter. The ocean responds to the shape of land, and in responding, it shapes climate in return. He sees the whole as a breathing machine that does not tire. Wind pushes, rotation curls, salt and cold pull. Heat arrives and is carried poleward by surface currents, then returned at depth, slower and denser. Chemistry rides along, sometimes lending weight, sometimes taking it away. Seafloor relief trips the flow and turns straight lines into loops. Tides lend energy where winds cannot reach. Even gravity waves that cross basins with the patience of months serve to nudge levels that tie one margin to another. The result is a conversation that never ends, a set of circuits that carry heat, salt, oxygen, carbon, silica, and life. At a rocky point above a narrow shelf, the sea performs the pattern plainly. A wind rises, surface water slides away, and cold water comes up to meet light. Foam carries the chill to air. A bank of cloud grows downwind as vapor condenses, and rain falls inland where rivers will carry the memory back in ions. Swell from a storm born far away leans on the shore and folds. Inside the break, rip currents return water seaward through slots, small conveyors that echo the grand ones. Behind the surf, a lagoon breathes with tide, and a channel cuts deeper each month until it connects with the shelf again. The coast is not an edge that ends anything. It is a throat where the ocean's breath is focused and made audible. He weighs a handful of sand and tastes the air that moves above it. The two are partners in a negotiation that never ends. Rain meets rock and freeze ions with quiet efficiency. Carbon dioxide dissolved in droplets makes a weak acid that pries sodium and potassium from feldspars, magnesium and calcium from mafic crystals, chloride and sulfate from minerals that once grew in volcanic breath. Streams carry the harvest to low places. The sea receives it, column by column, and the water learns a flavor that will persist longer than any shore. Salinity is not a spice. It is a memory of contact written in chemistry. Chloride becomes the simplest truth in that memory. Volcanoes exhale hydrogen chloride that the sky quickly translates into chloride in rain. Sodium arrives from weathered crust and finds chloride waiting. Together they build the main salt because they are difficult to remove once dissolved. Other ions shuttle through more elaborate cycles. Calcium enters as rain's prisoner and leaves when shells or cements pull it into carbonate. Magnesium is invited into mineral exchanges at spreading ridges and into clays that hide it on the seafloor. Potassium favors clay lattices near river mouths and does not stay long in the open water. Sulfate grows in importance as iron learns to rust and sulfur finds oxygen to bond with. Each ion secures a place and then submits to a ledger that seldom balances in a single season but does so convincingly over ages. On margins where evaporation outruns supply, the sea writes thick pages of salt that prove this algebra in stone. Water retreats to the sky and leaves brine to thicken. Gypsum precipitates when calcium meets sulfate. Halite falls when sodium has no more partners to hide behind. In the driest basins, potassium and magnesium salts stack in closing chapters, complex and rare. These evaporite sequences are not decorations of drought, they are valves. When they lock sodium and chloride into rock, they lower the salinity of the ocean by small but real amounts. When basins flood and dissolve, the ocean takes its ion loan back with interest. The result is a slow modulation of brine that never drifts far from a working range. At the seafloor, vents act as bookkeepers that balance other columns. Hydrothermal systems at ridges strip magnesium from seawater and return calcium and fresh metals. Basalts exchange sodium and calcium in reactions that change both stone and liquor. Serpentinization drinks water into the mantle's top layer and releases hydrogen that changes the taste of nearby chemistry. These flows and counterflows prevent monotony. Without them, rivers alone would push the sea toward a composition that would crust over shelves with carbonates and starve hydrothermal chimneys of vigor. With them, numbers settle into a range that allows both carbonate platforms and black smokers to thrive in their seasons. The air learns its role at the same time. Carbon moves between sky and sea in steps. Gas dissolves into the surface, becomes bicarbonate, and carbonate, as alkalinity dictates, travels on currents that do not show their roots to the eye, and returns to air where wind and temperature favor exhalation. Cooling brings more carbon into solution. Warming sends it out. When the sea grows rich in calcium and carbonate ions, minerals precipitate and lock carbon in lattice. When weathering intensifies, more bicarbonate flows seaward and raises the capacity of water to hold carbon without falling out as stone. This cycle operates as a thermostat that resists both fever and chill. Increase carbon dioxide in the air, and rain grows more acidic. Weathering accelerates, sending more alkalinity and cations to sea. Carbonate precipitation then increases, trimming the excess. Lower carbon dioxide, and the chain slows, yielding a push in the opposite direction. The ocean and the crust keep the sky inside a belt where water can keep its phases honest. Clarity becomes a byproduct of this exchange. Ash and haze settle as weathering steals their scaffolds. Sea spray injects tiny salt crystals that seed cloud droplets and teach the sky to hang mirrors over the bright surface. Where clouds thicken, albedo rises, and more light returns to space. Where clean air prevails, sunlight travels deeper in the column and warms the upper ocean with intent. The balance between aerosol-rich and aerosol-poor regimes carves patterns on latitude belts and along storm tracks. In both cases, blue finds space to speak. Air clears to a palette where molecules dominate scattering. Water clarifies until its own absorption spectrum decides the hue. Rayleigh scattering gives the sky its voice. Short wavelengths scatter more strongly than long ones by a factor that favors blue over red to a power almost theatrical in its bias. With dust and droplets in retreat, the heavens take this physical preference and show it without obstruction. The ocean answers not by mimicry, but by its own physics. Water welcomes red and infrared into heat, swallowing them in meters. Blue and green find less appetite and travel deeper. Where dissolved organic carbon and fine particles are few, the surface throws blue back to the eye, with a depth that feels like an idea more than a color. Where rivers pour tea-colored water and plankton bloom, green and even brown replace it. Even then, the cloudy greens speak of cycles working, of nutrients reaching light and returning to depth as bodies and shells. Salt helps the sky build itself daily. Breaking waves launch film drops and jet drops that dry into aerosol nuclei. Those nuclei draw vapor to themselves and nudge clouds into existence. In marine layers, salt particles govern droplet size distribution and therefore how much sunlight a cloud reflects. Small, numerous droplets brighten a deck and cool the surface below. Fewer, larger droplets dim and rain. The sea thus instructs the sky on how to wear its brightness. The negotiation is continuous. Wind fields shift. Biological activity changes organic coatings on particles, and the mix of sea salt with other aerosols from volcanoes or distant land modulates outcomes that eyes recognize as calm, brilliance, or opaque glare. Redox chemistry quietly reworks both reservoirs. As iron oxidizes in weathering profiles and in the ocean, it removes capacity to bind phosphate and trace metals in some settings and forces them to travel in others. Sulfur cycles between sulfide and sulfate, dragging metals along for rides and leaving some buried as ores, while others wander through water columns. These cycles alter how salt tastes to organisms that will eventually fill the sea, but even before life makes demands, the balance between reduced and oxidized species affects the color of the water and the stability of the sky. Methane, in a reducing air, lends warmth and haze. Oxygen, once it gathers, clears the column and changes the kind of blue the world wears at noon. The color that emerges is a verdict on many judges. Albedo tells how much brightness goes back to space. Absorption tells how much warmth stays. Scattering in air dictates the dome's tone. Scattering and absorption in water set the sea's shades. Salinity participates by controlling density and thus circulation, which moves heat to where it can sing or be silenced. Chemistry contributes by choosing whether carbon adorns the surface as gas or hides in limestone and deep waters. Geography edits by placing continents where they can feed rivers and break currents into gyres that sculpt the boundaries of warm and cool. On a calm day, the partnership is visible on a single stretch of coast. Waves break and lift salt to air. A band of low cloud appears along shore, its base drawn flat by a temperature inversion set by cool, upwelled water. Sunlight above that deck scatters into a dome clear enough to count its color. Offshore, a darker stripe reveals a plume where a river carries clay and dissolved organic carbon to sea, shifting the spectrum toward green. Beyond the plume, the water deepens into a blue that arrives from scattering and the selective hunger of the liquid itself. In the shallows near sandbars, tan and turquoise speak of grains reflecting and the bottom sending back white light filtered by a meter of clarity. Every shade is a measurement the eye can make without instrument, a calculus of salt, sky, and depth. Stability does not mean stillness. Storms spin, rivers flood, volcanoes breathe, and the ledger adjusts. Yet the long averages hold. Salinity remains within a narrow band because sources and sinks conspire. The sky keeps enough carbon dioxide for rain to feed weathering and for plants, when they arrive, to teach daylight to linger in sugars. The ocean hoards enough alkalinity to hold carbon without turning to stone everywhere. As a result, The world keeps a color that signals habitability to any distant watcher. Blue is a physics lesson sent outward as an announcement. It says that scattering molecules dominate over dust, that water is abundant, that the air is not an accident but a system, and that salt has found its right to remain without poisoning its host. Evening softens the contrast, but does not erase the logic. The sun slides lower, and red strengthens through longer paths in air. The sea takes on slate and silver, but a line of blue persists under the horizon where light travels least obstructed. After dark, the memory of the day lingers in dew forming on cooled surfaces and in winds relaxing as convection ceases. By morning, the cycle restarts. Weathering will send another measure of ions. Waves will shell more droplets into sky. Clouds will decide how open to leave the dome. The sea will adjust its breath between storing and releasing carbon. The world will polish its blue again, not as habit, but as the outcome of a discipline shared between salt and sky. He lays a transparent globe on its cradle and turns it slowly until seams appear that no light can show. Continents are not solitary achievements. They rehearse unions and partings, gather into bodies that span horizons, and break again along remembered lines. The cycle is simple in outline and intricate in execution. Ocean closes as plates converge. Mountains rise where edges meet and lock. Heat accumulates under the heavy quilt of thickened crust until the fabric loosens. Rifts open as quiet slits, widen into valleys, flood into gulfs, and finally split seaways into oceans. Coasts transform from jagged scars into long, calm shelves. The choreography repeats with different partners and tempos, leaving sutures, scars, and wide platforms as their handwriting. The first act begins when small blocks find each other under the guidance of long currents in the mantle. Island arcs ride basaltic plates toward pale keels and stitch themselves on with belts of metamorphosed rocks and intrusions. Microcontinents drift like beads along strings and dock one at a time. The edges speak the language of accretionary prisms, chaotic mixtures of mud and broken seamount that climb the side of a growing land. In the interior of the assembly, pale magmas pool and cool into bodies that will harden into kernels of future stability. The new mass rotates as a single unit. Rivers learn to cross it. A long coastline gives way to gulfs, and gulfs give way to a perimeter that smooths into curves. A full union changes the deep as much as the surface. Thickened crust acts like a lid set over a simmering pot. Mantle flow beneath slows and warms. Fluids ride up through roots and alter them. Lower crust transforms where pressure and temperature allow, making layers that may grow too dense to support themselves. These layers peel away in slices and fall, a shedding known by its signature in gravity and by its echo in uplift. The release lets mountains jump higher for a while. It also resets the balance that decides whether a great mass will hold or begin to pull apart. The interior of such a mass does not stay quiet. Heat trapped beneath finds paths upward. Domes rise where the crust softens. Basins subside nearby as weight shifts. Far from the margins, fault systems organize into patterns that reveal the stress field, choosing new priorities. Triple junctions of rifts try to form where the crust stretches evenly. Usually two succeed and one stalls. The successful pair lengthen and steer the next ocean. The stalled limb remains as a fossil valley that gathers rivers and sediment. When flood basalts pour from fissures during these beginnings, they announce not only a change in surface architecture, but also a change in the coupling between plate and mantle. Climate answers to the new geography. A single mass that spans latitudes develops interiors far from sea breeze and moisture. Monsoons grow along its edges if warm seas flank it. Deserts enlarge at its heart under clear skies. Mountain belts sear snow into the sky and feed weathering engines that draw carbon dioxide down. When the lid loosens and rifts widen, marine corridors flood those deserts and moisture returns. New coasts invite storms to pour inland. The chemistry of the ocean adjusts accordingly. Burial of carbon and delivery of ions change their cadence with each reorganization of mountains and shelves. The ocean's great loops alter their routes as seaways open or pinch, guiding heat to poles or quarantining it in gyres. As the new ocean spreads, passive margins take their long turn. Thermal subsidence lowers shelves in curves predictable enough to be drawn with an equation. Sediment delivered by rivers stacks into deltas that grow seaward, slip, and repair. Limestone reefs or microbial mounds, depending on the century, colonize warm shallows and build ridges that slow waves. The continents wear a fringe of fertile platforms where life multiplies and stores carbon. Inland, flexure responds to the weight on the edges. Some interiors deepen into gentle basins that gather sand and mud from fans that waned long ago. Others lift slightly and exfoliate like old paint. The contrast makes patterns on maps of thickness that tell their own story. The ocean born of this parting carves habits into the planet's breath. A ridge in the center lifts water, thins the column, and channels flow. Deep currents choose their lanes under the guidance of seafloor mountains and the new basin's shape. Western boundary currents sharpen and race, carrying warmth, poleward, and returning cool water in depth. Where the new ocean links to older basins through narrow straits, the exchange becomes a gate that the climate learns to respect. A favored gateway can make a hemisphere gentle or severe by choosing how to route heat and salt. In time, the ocean that grew from rifts becomes an agent of closure. Subduction zones line parts of its rim. The floor ages, cools, and grows dense enough to prefer descent. Arcs ignite above the zones, stitching beads of volcanoes that will one day match along a suture when the gap closes. The continents begin to converge again, drawn by motion at their margins rather than by any will of their own. The sea narrows into a wedge of water flanked by rising belts. Sediment that once spread freely now funnels into trenches and foredeeps. The long shelves lose their confidence, and small basins trapped between arcs and keels begin to tell the future shape of a new union. Collision is not only a meeting, it is an unmaking and a making together. Edges crumple and ride over each other. Slabs jam or break. Roots thicken to twice their original depth. Pressure and heat bend rocks into folds and melt pockets into bodies that will cool as granite. Rivers reverse directions as slopes change. Lakes trap themselves in high basins where flexure makes space. The air changes composition a little when metamorphic reactions release carbon dioxide and water. Erosion sharpens ranges, cutting them into young forms that stand until rivers and glaciers drag their measure back to the sea. The new continent learns to carry this weight as if it had always known how. Signals of these rehearsals accumulate in quiet witnesses. Minerals that grow during the peak of pressure and temperature set clocks that chime in unison along the length of a suture. Detrital grains in river deposits record peaks of ages that reflect the timing of mountain building and the growth of continental crust. Magnetic directions frozen into basalts fix latitudes and orientations so that reconstructions can be spun from data like a child's toy top set spinning by puffs of numbers. The paths trace arcs that sometimes loop because the whole shell reorients to follow mass, a wonder that shifts climates without moving plates. Even that reorientation has its rhythm, tied to how continents assemble and act as blankets or mirrors for heat. During quiet spans between collisions, the long platforms that margin older keels capture uniform layers of limestone and shale. Then, in a sudden few million years, a basaltic flood arrives, a flare from deep that arches surfaces and resets river courses. These large eruptions coincide often enough with turning points in the cycle to be suspect. They may be the uprising of heat trapped under continents near the end of an assembly, or the first yawn of a rift that will become an ocean. Their ash drifts through clouds and oceans, paints thin lines across basins, and allows later readers to align shelves separated by whole seas. Life listens and adjusts to each geography. When a supercontinent sprawls, species spread across low barriers and lose regional accents. When that mass breaks and seas invade, islands of evolution bloom apart from one another and invent new forms. The distribution of reefs, forests, deserts, and lakes rearranges as belts of rain shift with latitude and mountain height. Carbon burial surges on shelves during warm, high sea stands and ebbs when coastlines withdraw. Oxygen wavers in deep water depending on circulation and nutrient loads. These shifts feel like weather to a microbe and like destiny to a lineage. They become geology when shells and wood and microbial mats accumulate into stone. The cycle inscribes even the deep mantle. As continents gather, the blanket above grows. Heat pools, and the mantle under the center slows, while upwellings prefer the edges or break through at weakness. As the mass breaks, the deep rebalances. Plumes find new lanes. Slabs that had been stacked sink to depths where they rest as cold shadows. Their influence lingers as anomalies that steer later flows. The planet remembers in its interior everything it has done at the surface. When new edges are born, they inherit this invisible memory as differences in vigor and style. The globe on its cradle does not show the colors of these eras, but the pattern can be traced with a finger. Arcs and sutures ring old cores like growth lines. Rift valleys cross platforms and point toward margins now passive and rich in layered stories. Highlands and basins look random until gravity and magnetics pull translucent threads between them. Follow those threads, and a map of rehearsals appears. Each union refined a method. Each parting improved a seam. The practice produced continents with bones strong enough to last, and oceans with habits strong enough to give climate its voice. He spins the globe once more, and stops it with a palm over a margin that looks calm today. A shelf slopes gently into a wide basin. Far offshore, a ridge rises a little above the average deep. Along the far edge, trenches sip older floor. In time, motion will carry this corner toward another shore or invite a rift to cut it free. The certainty is not in the route, but in the rhythm. Assembly will return. Breakup will follow. Edges will draft themselves and offer stages for rivers, reefs, dunes, and deltas. The world does not tire of the exercise because it is how heat leaves and how rock learns to float. The rehearsal is its own performance, and the continents it produces are the long, eloquent pauses between acts. He follows a tide that brings no footsteps, yet leaves patterns only the living can draft. On a flat of lime mud, ripples comb themselves into rows, and over them a film slides that darkens in sun and pales in shade. The film is a city only a millimeter tall. Cells knit themselves into mats that trap sand, glue silt, and hold their own shade with pigments tuned to light older air once filtered differently. Cyanobacteria drink photons and exhale oxygen in whispers at first. Then, in steady song, when the sea grants them calm and shallow water that renews with each tide. Their labor changes the coast grain by grain, binding a margin that would otherwise wander with every breeze. Where mats persist, they raise low domes. Microbial laminations catch another tide's drift of grains and preserve it beneath a new layer of life. Over seasons and longer, the mounds grow into columns, cones, or layered pavements, each a record of daily compromise with waves, storms, and sunlight. These structures are microbialites when any community builds them, and stromatolites when the lamination is crisp from years of alternation between calm growth and windy repair. The coast wears them like teeth and knuckles, hard enough to break small waves into lace and to redirect the next pulse of sediment downcurrent. In those swales and eddies, chemistry finds time to settle and begin again. Oxygen accumulates close to these mats in small pockets that move with waveset and tidal slosh. Iron dissolved in anoxic water meets this gas and falls as rust, staining the mud with halos around living patches. Day and night, light and dark pulses govern a breathing that is local at first. Elsewhere, the dissolved gas finds a different fate. In the open sea, reduced species in solution take the first claim until they are spent. When that quiet inventory drains, the gas wanders more freely. Coastlines under persistent bloom watch the sea's redox journey mark its thresholds in sediment color and mineral species. Banded iron stops appearing with regularity once oxygen learns to claim space even in water that has traveled long from shore. Not all mats live on flats. Around vents where warm alkaline water meets the sea, minerals precipitate on microbial scaffolds that use proton gradients and the riches of reduced compounds to build more scaffolds. Towers with pores and terraces of carbonate and silica grow into gardens where flows split and rejoin in circuits the eye can follow. These gardens alter the chemistry of plumes and the texture of nearby sediment. They also train the coast to sustain steep microgradients, and those gradients make later life possible by teaching it where to sit and how to borrow energy from borders rather than from bulk. As oxygen rises, air and sea adjust. Sulfur shifts allegiance from sulfide to sulfate. Iron learns to parking lot itself as oxides that grains of magnetite and hematite remember. Manganese toggles between dark and pale states. Phosphorus clings differently to mineral surfaces when redox changes, affecting how rivers feed the sea. The coast feels these changes as a new rhythm in precipitation and dissolution. Carbonate finds it easier to grow where oxygen keeps hydrogen sulfide at bay. In those places, beaches brighten and banks harden. Oids, tiny coated grains, roll in shallow water where supersaturation and agitation conspire. They accumulate in shoals that march shore parallel and send signals downstream into deltas deciding whether to bifurcate or braid. Eukaryotes test the margin as waters clear, and nutrients find cycles that suit invention. Soft-bodied forms graze mats and disturb layers that once lay undisturbed. Burrowing starts as faint tick marks and crescents, then deepens into galleries that ventilate the topmost sediment. The change is radical. Microbial rugs that once trapped grains now are grazed and torn. The substrate begins to mix, oxygen penetrates, and the chemical stratification that produced lamination relaxes. Sediment becomes a living composite, a loose skin pumped by animals that breathe as they work. The geometry of ripples changes too, as worm tubes and crab burrows baffle flows and anchor grains that would migrate under lesser hold. Reefs evolve from microbial causeways into frameworks that can resist swell by force of scaffold and skeleton. Early sponge-like builders, archaeocyathid gardens, then corals and coralline algae learn to turn bicarbonate into structures that do not slump when storms shove. These bioconstructors occupy wave base and just above, transforming shore energy into small turbulence and foam. Behind them, lagoons quiet, allowing finer sediments to fall and seagrass meadows to root. The coast acquires rooms and corridors. Fish find nurseries, shelled grazers find kitchens. Carbonate mounds rise that later become headlands when sea levels fall and reef. Limestone meets air and rain. The wave climate shifts, the sediment budget changes, and new deltas must answer a transformed shelf. Plants climb land and rewrite the relationship between ridge and sea. Roots pry open joints, soils thicken, and organic acids accelerate chemical weathering. Rivers steepen their competence in floods but deliver finer loads through most seasons as vegetation slows hill slopes and stores water. Channels stop wandering freely across their floodplains and accept banks strengthened by roots. Meanders tighten, scroll bars archive each turn. Floodplain clays amplify their cation exchange because leaves donate carbon to soils. Phosphorus cycles through litter and returns in forms that rivers can carry farther. At the mouth, finer sediment spreads broader and feeds marshes. The coast inherits resilience. It now repairs storm cuts with peat growth and new shoots. With forests and later flowering plants, transpiration increases and rain patterns reorganize. Monsoons strengthen along warm coasts. Seasonal rivers carve distributary channels and rejoin. Estuaries widen under sea level pulses that rise and fall with ice. Where sea meets river under these regimes, gradients in salinity become architecture that anchors communities. Oyster beds fix sediment while filtering water. Salt marsh grasses knit mud into slabs. Mangroves trap silt with knees and aerial roots, pushing shorelines seaward while building soils that can store storm energy instead of breaking beneath it. These biogenic edges are not barriers. They are baffles that lower the tone of violence and increase the longevity of shape. Carbon burial changes its tempo with every ecological advance. Microbial mats store carbon in carbonate crusts and in organics that oxidize quickly when disturbed. With burrowers, more carbon oxygenates, yet more also travels deeper with fecal pellets and mixed sediment to be buried below oxygen's reach. Reefs sequester carbon as calcite and aragonite, and act as breakwaters that reduce erosion of organic rich backwaters. Forests store carbon in wood and soils, send dissolved organic matter down rivers, and shuttle particulate organics into deltas where they bury under rapid sedimentation. Each increment of biological engineering modifies the thermostat that balances air and sea. The coast becomes a central switchboard for the planet's carbon budget, able to draw down heat slowly or release it if stripped. Noise in the sedimentary record quiets where life settles into routines. Laminations give way to bioturbated fabrics, dappled with traces of behaviors. Scolithos stands upright in high-energy sands. Cruziana scrolls across lower-energy beds. Thalassinoids riddles firm grounds with boxwork. These ichnofabrics are calendars and barometers. They mark oxygen penetration, energy levels, and colonization windows between storms. Layer by layer, the coast writes the story of how animals learned to live inside the substrate, and how that choice fed back into shoreline stability by tightening the top few decimeters against sudden failure. Not every invention stabilizes. Grazers strip mats and allow sand to run, then builders arrive and rebuild. Herbivorous fishes bite living coral and keep reefs growing by pruning. Sea urchins overgraze and turn a forest of algae into an urchin barren until predators return and rebalance the ledger. Shorebirds rake flats and resuspend fine particles at low tide, slightly raising turbidity that then changes when light returns to meadow and mat. The coast is a parliament of motives where no single party rules. That parliament produces resilience because no one method of building or defending holds absolute sway. Storms test these arrangements, and the living edge adapts by storing memory in geometry. Dunes march inland and back out, while grasses catch sand and rebuild crests. Barrier islands overwash and leave washover fans that seed new ridges downwind of gaps. Marshes drown and rebuild vertical height by trapping silt on each flood tide and by growing peat. Reef crests break and heal as corals that tolerate rubble take the first hold, then hand the lattice to species that prefer calm. Ruin becomes scaffolding, damage becomes template. The system gains an ability to turn shocks into cues for construction. He reads the chemistry of shells to follow climate where thermometers did not yet exist. Ratios of oxygen isotopes reveal temperatures and ice volumes. Strontium calibrates seawater curves that fix ages. Boron speaks about pH. In layers of coral heads and in thin layers of travertine cementing beach rock, these traces record the push and pull of sea level and the swings of storms and drought. Living engineers write their own archives in structures that keep coasts in place. Future rivers will cut those archives. Future waves will leave them stranded as terraces. The record will travel inland as cliffs and out to sea as drowned banks. On a quiet morning, the shore is a conversation without raised voices. Mats darken with light, shells open, grass blades lift salt from pores. A crab draws a coil of sand from a burrow mouth and trims it into pellets. A school of small fish scatters into a sun patch where plankton rise on the tide and fall back as currents turn. Above the reef crest, spray flares as a line of white that never quite repeats itself. Every gesture edits the margin slightly. Every edit changes the way the next wave arrives and the way the next pulse of silt will settle. The coast remains a meeting, but the meeting now has guests who rearrange the furniture as they sit. The edge gains purpose as well as form, and in that purpose the planet learns to hold its shapes longer than physics alone could manage. He enters a room where the planet lies on a table with wires and lights surrounding it, not as a patient but as a witness. Screens flicker with colors that mean nothing until the mind remembers that sound takes longer through soft, warm rock than through cold, stiff rock. Seismology has learned to throw earthquakes back upon themselves and catch the echoes. Waves circle the globe, bend at boundaries, scatter from slabs, and carry delays that are turned into images. Tomography stacks these delays into volumes. Under continents appear dark roots that slow the waves. Under oceans hang curtains that were once floors, now fallen toward the deep. The picture is imperfect and alive, a memory printed in textures where no eye can travel. In those volumes, Cold streaks dive from trenches toward a horizon inside the Earth, where a change in mineral structure slows them. Some of these streaks flatten and pool like syrup that refuses a lower shelf, evidence that subducted crust can rest before inching down again. Other streaks tilt and pierce deeper, passing into the bottom third of the mantle where pressure writes matter into new arrangements. Suspended near the base sit vast provinces that alter the path of waves as if they were continents of the deep. Whether they are ancient cumulates, recycled mass in piles, or something stranger, they anchor upwellings that later choose where to light fire at the surface. The map becomes a story of movement with the names removed, a choreography of sinking and rising that says continents and oceans do not drift alone. They are tugged and lifted by relics hidden far below. Another screen shows the surface blanketed with dots that mark where instruments measure the pull of the planet. Gravity anomalies arise when density varies. Long wavelengths speak of deep architecture. Short wavelengths paint the distribution of basins, mountains, and keels. Where gravity is low above thick crust, the signal suggests buoyant roots. Where it is high over basins filled with dense sediments, flexure, and infill answer to load and subsidence. When gravity is stacked with magnetics and electromagnetic conductivity, sutures appear that no ridge of hills betrays. Old oceans that closed long ago leave belts of altered mantle that conduct electricity more readily. When maps of these belts cross maps of seismic anisotropy that mark fabric directions, an atlas of buried stitches is born. He turns to clocks that were wound when crystals grew and that still keep time faithfully. Uranium becomes lead, while zircon holds both in separate corners. Lu decays to IF in zircon and garnet and writes a chronology of how much crust has separated from mantle. SM becomes Nuda in a pace that survives heat and weather. Remeasures Tuos in sulfides and tells when the ocean was more influenced by mantle or by land. Each isotope pair speaks with a different cadence and sensitivity. Combined, they read like an ensemble that can specify not only when a rock cooled, but also whether its source was fresh mantle or recycled crust. Plotting epsilon values against ages lays a curve that rises when continents grow and flattens when erosion and recycling dominate. Thin slabs of river sand rest under a microscope where detrital minerals confess their provenance. Zircon, rutile, and monazite carry internal structures that show metamorphic temperature and source lithology. Electron microprobe spots and laser ablation trails map trace elements. When the ages of thousands of these grains are stacked, the peaks align with episodes of crustal generation. A river that today crosses deserts may carry a hidden signature of a mountain belt ground flat long ago. Follow the grains downstream across shelves and into deep sea fans, and the sedimentary stream becomes a time machine. In that machine, the first drafts of edges that once held back oceans can be rebuilt from crumbs. Magnetic stripes on the seafloor act as a tuning fork for time. When lava cools, its iron-bearing minerals align with the present field. Over millions of years, the field flips, and new stripes form with opposite polarity. Taus of magnetometers trace these bands on either side of ridges, mirror images widening together. Counting the stripes and measuring their widths turn into spreading rates. Where stripes end abruptly at trenches, consumption of floor is recorded. Coupled with paleomagnetic inclinations on land that fix latitude for ancient rocks, the geometry of plates falls into place like gears clicking back into a watch. Circuits close where continents that now face different oceans once snuggled and shared a shoreline. Light itself times layers in the quiet places between storms. Cyclostratigraphy reads the small rhythmic variations in bedding that echo how the tilt of the planet, the wobble of its axis, and the shape of its orbit modulate climate. Thick carbonate sequences carry bundles of laminae grouped in 4s and 5s, a cadence that matches the beats of precession and obliquity. Shales wax and wane in thickness, with orbital forcing that governed winds and rains. Astrochronology brings those cycles into alignment with celestial mechanics and gives sedimentary clocks minute hands. When these hands are aligned with isotope ages, the past stops being a sketch and gains a metronome. He walks from physics to chemistry without a pause because the Earth refuses to keep those trades apart. Noble gases float aloof from many reactions, so their proportions map sources from mantle to air to space. Helium, 3 whispers of primordial reservoirs and mid-ocean ridges. Xenon isotopes, remember the time when the atmosphere learned to hold on to itself. Argon carries the decay products of potassium and gives a second opinion wherever thermal histories threaten to erase other clocks. When noble gas ratios in volcanic glasses disagree with those in ancient fluid inclusions, the difference reveals how much recycling has altered the mantle source. Oceans and continents leave their taste in the mantle, if given enough time. In the dark of deep laboratories, scintillators count neutrinos that pass through everything but occasionally surrender a trace. Geoneutrinos originate in the decay of uranium and thorium within the planet. The rate at which they arrive tells how much heat remains to drive motion. If their flux is higher beneath stable cratons than beneath young arcs, one conclusion follows. If it is reversed, another follows. A map of internal radiogenic heat is not a photograph, but it constrains the engines that move plates and feed rifts. This map is young as a field, yet it is already refining arguments about how quickly the mantle cooled and when plates first found ways to slide. At the scale of a mineral lattice, defects and inclusions behave as faint logbooks. Water molecules wedged into ringwoodite tell that the transition zone can store oceans worth of hydrogen if pressure lends it room. Exsolved phases in perovskite, derived grains, rescued by kimberlites, betray iron in states that set redox. Trace metal zoning in garnets from ancient metamorphic belts draws time-temperature tracks that cross fields of pressure. With each micron-scale observation, the past gains coordinates. With each coordinate, competing diagrams of geologic episodes give way to paths. Some memories ride in topography that never sees the light. Abyssal hills march away from ridges at angles that record faults frozen into young crust. Subdued lineations on abyssal plains point to direction of flow in the deep. Contorites collect where deep currents sweep, their drifts climbing like dunes on a slope no eye can see. Turbidites that break the calm stack repeated fining upward packages, punctuated by muds that mark quiet days. Coring adrift and reading its faces reveals the evolution of a bottom current that remembers when a gateway opened or a wind pattern changed. Those openings and changes tie to plate motions that shift coasts and to mountains that shelter basins. He sets thin plates of carbonate into a mass spectrometer tuned for clumped isotopes. Heavy carbon and heavy oxygen sometimes choose each other, and how often they do so depends on temperature at formation. This thermometer ignores brine chemistry and reads the ambient water. Atolls that built rings in warm seas and limestones grown in cool upwellings separate cleanly in this measure. Stack clumped temperatures against depth habitats and against foraminiferal oxygen isotopes, and the water column of a vanished ocean can be contoured with care. The picture shows where cold water rose, where warm tongues reached poleward, and where coastlines must have helped or resisted those flows. He returns to the screens where all of this is fused. Joint inversions take seismic velocities, electrical conductivities, gravity fields, and heat flow, then search for models that satisfy them together. Bayesian maps show confidence in colors for each property. Slices through the mantle reveal pathways where slabs align with gravity lows and cool spots in conductivity. Overlay detrital zircon age peaks, and sutures coincide with regions where slabs rest. Overlay thermochronology and uplift events match delamination signatures. Overlay paleomagnetism and rotations of blocks explain offsets in belt trends. The past tightens into a shape that could have drifted this shelf against that ridge and could have allowed this sea to flood that plain. Memory is selective, and he accepts that. Rocks have been heated and reset. Minerals have been dissolved and reprecipitated. Stripes on the seafloor vanish where subduction has fed them to the deep. Even so, a minimum surface of truth connects the surviving points. Early edges can be redrawn where roots persist under shields, where sutures refuse to forget their conductivity, where detrital grains pile age peaks that agree across a hemisphere. Oceans long swallowed can be reimagined where their last turbulence is preserved in contorites and where their chemistry remains in the isotopic taste of carbonates. The reconstruction is not nostalgia, it is testable belief. He steps away from the table and its maps. The method is clear now. Shake the planet with its own quakes and read the time it takes for waves to cross. Weigh it with gravity and follow the faintest changes in pull. Slice it with fields and see where electricity prefers to flow. Date it with atoms that refuse to lie. Count rhythms that orbit inscribed in mud. Interrogate defects in minerals that were buried as far as any drill can dream. Let neutrinos, indifferent and honest, speak for heat in the dark. Then, place every answer on the same grid and see what images persist through contradiction. Those images are the planet's memory made visible. In them are the first essences of edges, the first rehearsals of basins, the first regions where pale magmas rose and refused to sink. The memory has been coaxed into a map, and the map has learned to talk. He gathers the arguments at a narrow table and invites each to speak plainly. One voice claims that heat alone could sculpt a world. Plumes rise from deep reservoirs, crest and distill light magmas from dark sources through repeated melting. Buoyant caps accrue over long seasons of fire. Continents, in this telling, are the husks of many boilings, their roots dehydrated and resistant, their faces paled by cumulative extraction. Plates are optional. Motion exists as broad sag and lift, as foundering deltas of melt, as a breathing lid that exudes warmth like a banked stove. Across the table, another voice refuses to leave trenches out of the origin story. Even in a hot mantle, slabs can begin in short segments where water seeps downward, grain sizes fall, and strength collapses into narrow bands. Drips detach, then longer pieces follow. Hydration lowers the melting point of basalt, returning to pressure, birthing tonalites and their kin. Buoyancy then builds in leaps. Pale magmas rise in arcs, stitch small blocks into larger, and leave keels of depleted mantle welded beneath them. The engine is recycling. Without dissent, the argument insists there is no rapid path to chemically buoyant crust. Between these standings sits a compromise that calls itself a hinge. Early continents, it says, were assembled by many tools working in sequence. Plumes supplied fertile basaltic plateaus and kept the surface flexible. Impacts punched weaknesses through the lid and hydrated them. Tides needed margins and promoted reactions that soften olivine and pyroxene. Drips carried dense lower crust away and lightened residual roofs. Short-run subduction organized along corridors already softened by these acts. No single lever moved the world. Many levers nudged it across thresholds, one after another. A fourth voice argues for overturns inherited from the last magma ocean, when crystallization sorted the mantle into dense cumulates below and lighter residues above. Staggered collapses followed. The collapses fed primitive slabs downward and lifted buoyant material into domes where pale magmas incubated without needing trenches or plumes. Continents are survivors of these initial physics, their keels sculpted before modern circulation found its lanes. Later plate behavior merely edited a draft already robust. The room holds its breath for tests. Theories without wagers are indulgences. Predict the observables, the hinge proposes, and see who pays when the bill of data arrives. If plumes dominated distillation, the oldest continental cores should be crowned by volcanic sequences with trace element signatures that match long-lived upwellings, and their underlying mantle residues should show extreme depletion without the aqueous fingerprints of slab fluids. If hydrated descent dominated, TTG suites should cluster beside ancient arc terrains, and zircon chemistry should couple heavy oxygen with depleted hafnium in patterns that match remelted basalt altered at low temperature. Another prediction tests the memory of sinking. If delamination and drips were crucial, deep tomography should reveal patches of eclogite, like cool islands at the base of the upper mantle under ancient provinces, and the timing of uplift inferred from low-temperature thermochronology should align with moments when those patches detached. If overturn was the architect, The age of keels should predate widespread signatures of organized subduction, and mantle xenoliths from those keels should carry residue patterns consistent with high-pressure cumulative sorting rather than low-pressure arc extraction. Water budgets write the next wages. If tides and early regassing set the hinge, then markers of hydration deep in the mantle transition zone should be common beneath margins that birthed the oldest buoyant blocks, and geoneutrino maps of radiogenic heat should show deficits beneath those same blocks if extraction and dehydration were vigorous enough to starve the roots of heat-producing elements. If water mattered little, these coincidences should fail and dry keels should appear above mantle that shows no special signature of trapped hydrogen. Tidal dissipation also places a bet. If deformation at coastal lithosphere by large tides helped localize weakness, sedimentary rhythms in very old basins should carry tidal frequencies with amplitudes that align with modeled proximity of the moon at the time, and those basins should lie along trends later exploited by rifts and subduction nucleation. If the moon was a bystander, paleotidal rhythmites and later plate boundaries should share no special alignment. Impacts make their own demands. If craters seeded corridors for descent, belts of ancient igneous rocks should radiate from large impact basins as resurgent magmatism, and fault fabrics should display radial and concentric patterns at scales far exceeding volcanic provinces without impact ancestry. If those patterns are ghosts or biased sampling, the claim thins. Heat pipe devotees submit à différents audits. If vertical volcanism carried heat efficiently, vast provinces of layered basalt should stack with minimal intervening sediments and carry cooling rates fast enough to mimic plate-style heat loss before slabs became routine. Thermophysical properties of these provinces, read from vesicle-sized distributions and thermal remnants, should show a planetary heat pipeline in action. The hinge asks the ocean for testimony. If early continents relied on arc magmatism, the ratio of radiogenic to unradiogenic osmium in sediments should bend early toward continental influence as mountain belts supplied metals. If plume and delamination chemistry dominated without much uplift, that curve should lag. Clumped isotope thermometry in the oldest carbonates can weigh in by revealing whether shallow seas sat above warm lids supplied by plumes or above cooler margins ventilated by nascent circulation. Experiments join the tribunal. Deformation of wet olivine at pressures matching the shallow mantle should produce grain-size sensitive creep thresholds measurable enough to predict when bands of weakness focus. If those thresholds are low, slab initiation by hydration looks easy. If they are high, plume heating or impact weakening must share the blame. Atomistic simulations of trace hydrogen in bridgemanite can test whether deep reservoirs of water made the mantle more viscous or more slippery, changing the ease with which overturn and plume necking proceed. Analog tanks can try tidal kneading on wax lids by adding oscillatory loads that mimic moving bulges. If fractures align with the oscillation in repeatable patterns, tides gain leverage. If not, other actors keep the lead. Data assimilation frameworks can stage the final debate by inverting for rheology given histories of surface, uplift, subsidence, and magmatic flux with priors that encode each model's bias. Where posterior distributions converge regardless of prior, the planet has spoken. Where they remain split, more measurements must be designed. Theories do not only compete, they also define the edges of possible Earths. Shift interior water downward by a modest fraction, and slabs struggle. Continents become smaller, younger, and fewer. Raise tidal energy, and rifts align with coastlines more often, birthing narrow oceans that fail and restart. Reduce impact flux and corridors of weakness thin, raise it and lids reset too often for keels to consolidate. Warm the mantle a little further, and heat pipes dominate longer, leaving a basalt world with wandering rafts. Cool it sooner, and subduction organizes quickly, with continents arriving in haste, but perhaps without the deep, dry keels that buy longevity. At the hinge sits sensitivity, the slope of outcome against small change in cause. Water is the steepest slope. Rheology follows, especially the feedback between damage and grain size. Heat production sets the baseline, modulated by how quickly the core shed its early fever and through a roof of magnetism to save the air. Geography of deep reservoirs chooses the stage by biasing where plumes rise. Tides and impacts time the cues by offering moments to push systems across thresholds. Theories at this hinge are not mutually exclusive stories. They are weights on levers, each with a moment arm that lengthens or shortens as conditions change. Futures for testing multiply. Drill to basement beneath the oldest passive margins and read the first platform sediments for tidal signatures and ash fingerprints. Target cratonic roots with dense arrays of magnetotelluric stations to map hydration patterns at depth. Hunt for eclogite pools with high-frequency body wave scattering surveys. Expand geoneutrino observatories onto shields and arcs to map radiogenic heat with contrasting routes. Push diamond anvil experiments to quantify water storage in transition zone minerals at compositions matching mantle xenoliths. Sequence atom-scale defects in ancient zircons to reconstruct the water content of their magmas with new thermodynamic calibrations. Each test shifts a knob on the hinge and registers the click. He ends the session with an image small enough to fit in a hand. A stone polished into a thin slice shows grains meeting along triple junctions, some curved, some pinned by minute inclusions. Add water, boundaries migrate. Remove it, boundaries lock. Warm the slice, strain localizes. Cool it, strain spreads. This microcosm is the hinge scaled down. Continents and oceans were decisions made at contact lines, at defects, at the places where structure and chemistry guided motion across thresholds. Theories ask which contact held the most power. The planet answers along many scales at once. The hinge is not a single door swinging to reveal a new room. It is a framework with many pins that must align. When enough pins catch, the door moves with little force. When a few stick, effort must come from elsewhere. The story of the first coasts is the story of alignment. Fire, water, rock, tide, impact, and the slow moral of heat found their moments. Models cannot be crowned. They can be tuned to the notes the world still plays. In that tuning, the argument becomes less about triumph and more about harmony, a physics that allows edges to become durable without ever growing rigid, a negotiation that never ends and never quite repeats itself. He stands where water speaks a low grammar to stone and listens for what the lesson means. The edge he studies is not a line but a practice, a way of holding tension without tearing. A coast is where patience becomes visible. Rock keeps its angle, water keeps its rhythm, air keeps its distance while borrowing color from both. The meeting is never finished, yet it keeps its shape across seasons longer than any memory of a single life. From this, he draws the first hint of a philosophy. Continuity is not stasis. Continuity is a choir of changes that cancel their extremes. Time here is not the clock on a wrist. It is the weight of repetition. Waves add and subtract without keeping what they touch, yet they leave a term that persists. A beach repositions its grains, as if counting itself every day. A headland yields a pebble at a rate too slow for sightseeing and too sure for denial. He watches the ledger accumulate behind his back. The lesson is gentle and stern. What endures is not what refuses to move. What endures is what can move and still remain itself. He looks inland and understands that continents are schools in that art. A continent is not a wall against the sea. It is a conversation partner. It rises from differences it learned to internalize. It carries a memory of light magmas that lifted it and of darker ones that tested its resolve. It wears mountains like brief vows, lakes like commas, and plains like long clauses that let rivers make their arguments without sarcasm. The continent is slow because it knows how to wait. Waiting is not idleness. Waiting is selecting which change to accept. Outward, the ocean breathes with a longer chest. It chooses loops that reconcile wind and weight, salt and chill. It migrates heat like a shepherd driving flocks between valleys. It takes what rivers confess and returns that confession as the taste of brine. It responds to nudges with patience and sometimes with surprise. The ocean is an ethic of inclusion. It carries every ion that visits and loses almost none. Its color is an oath that light and scattering can share a premise. Edges become mirrors for what thought wishes to learn. Where a cliff yields, it does not consider the wave an enemy. Where a marsh accretes, it does not consider the river a trespasser. Where a reef breaks, swells into lace, it neither hoards nor surrenders entirely. These gestures are strategies of survival that feel like manners. A margin keeps form by distributing force. The pattern is consistent across scales. A grain stack resists by sharing load. A beach cusp stands by sorting energy into rhythm. A delta persists by forking its burden. A craton lasts by coupling a dry root to a flexible lid. The mind that watches can borrow these methods. It can spread the weight of change, sort its energies, fork its obligations, root itself without becoming brittle. He imagines a pupil asking what all this says about origin and purpose. The planet answers with function before it risks, meaning heat must leave, gravity must allocate, water must find its phase. Chemistry must pair and divorce according to stability. Yet this is not a reduction. Function here builds form here builds possibility. Possibility then invites interpretation. A coast does not ask to be admired, yet it accepts the gaze and returns it transformed. The eye carries away not just an image, but an argument for measured lives. He considers error and finds a place for it. There were times when ocean pooled too high, and times when ice taught knife work to valleys. There were moments when plumes drew curtains of fire across provinces that had believed themselves beyond rehearsal. Edges lost composure and found it again. The planet did not fail when it swung wide. It practiced range. A shoreline that moves a kilometer in a century is not poorly drawn. It is alive. A subduction zone that shifts its appetite is not indecisive. It is responsive to pantry and stove. The grace to accept this saves thought from false certainty. Language inevitably drifts toward metaphors of home. He resists the shallow versions and keeps one deep. A home is a place where return does not cancel the road taken. Continents and oceans are such places. They offer cycles that do not scold history for repeating. They correct with small measures and repair with quiet hands. They do not fear the accumulation of scars. Scars become the best maps. The scar of a suture directs rivers for ages. The scar of an old reef sets the line of a future headland. The scar of a drowned shelf tells fish where to winter and pilots where not to cut corners. The planet wears its healing as an index of what to try next. He imagines a shore empty of witnesses, night, stars, a wind he cannot hear. Even then, the same work goes on. Foam writes its runes and erases them. Longshore drift carries a handful of quartz from inlet to spit and leaves it there to glitter in a moon slice. A submerged bar migrates a meter and recalibrates the tone of the surf. Humanity does not become irrelevant in this absence. It becomes humble. The coast is not a theatre built for an audience. The audience learns to be a citizen by watching theatre that does not need it. The lessons reach into conduct. He hears in the edge a refusal to argue from absolutes. The healthy coast is a compromise between storm and calm, between flood and drought, between cliff and bank. It is a zone where no single actor can win forever. Authority rotates with the season and with the rare event that arrives once in a century. The fairness is not moral in any sentimental sense. It is practical. Systems that cling to one rule until the rule breaks disappear. Systems that change their rules keep their names. This is a prescription for how to live without pretending to be immune to physics. Memory translates into responsibility. If the margin is a practice, it can be weakened by neglect and strengthened by attention. Dunes without grasses run away. Mud without roots collapses. Reefs without herbivores drown in their own shade. A river, unbraided, starved of its own sediment, will cut its banks at the first persuasive flood. These are not prophecies. They are options written in habit. The antidotes are not poems. They are arrangements that reinforce the crowding of small strengths. Plant, protect, restore, allow room. The edge asks for space more than it asks for rescue. He bends to touch a cobble and finds it colder than the air. Cold is not a judgment, it is a record of heat that left. In the deep, the old slabs rest even colder, ghosts that continue to inform where warmth can rise and where it will be deflected. The body is in that logic as well. Blood carries heat from core to skin, recirculates it, and returns it. Breath trades gas across a margin as soft as a wave across a bar. Thought itself appears to consolidate from repeated small exchanges between impulse and control. The line that holds a person together rhymes with the line that holds a continent to an ocean. He lifts his eyes to the horizon and allows himself a last practical vision. Edges will move. Some will retreat as ice lets fall whole shelves of cold and adds water to the shapes. Some will advance where sediment is delivered faster than waves can lift it away. Some will grow more intricate where life thickens and slows the water, where reefs build and marshes stack. The policy he draws from this is simply in alignment with what works. Strength without rigidity, motion without loss of identity, sharing of force, preference for feedbacks that damp rather than amplify, refusal to pretend a line can be fixed by decree against a body that does not believe in decrees. When he walks away, the shore is the same and different in a trivial measure. 3 waves have arrived and vanished. A dark band of wet sand widens and narrows with the last run-up. A gull marks its claim and lifts. Nothing of consequence has changed, and everything that guarantees consequence is at work. The world's beauty is not a glaze on top of function. It is what function looks like when it takes the time to discover its best habits. Continents and oceans made that choice early and keep making it. Their conversation is the most patient art he knows. He closes his eyes and lets the planet speak without nouns. A tone rises from stone, low and certain, a hum that says wait remembers. Over it drifts a higher line from water, ribbons of cadence that carry warmth and salt and a rumour of long journeys. Between them floats the thin silver of air, quick and generous, folding light into colour and dusk into sleep. These 3 sing a chord that does not resolve because it is not supposed to. It hangs and deepens. It writes its own horizon. In that chord, a childhood of coastlines returns, not as a catalogue, but as a pulse, a flat where ripples counted wind, a cliff that taught echo the size of silence, a jetty that learned to translate storm into spray and laughter. None of these places exists as it was. All of them exist as they are meant to be, variations that keep a melody even as verses change. He knows then that origin stories matter less for the fireworks they promise than for the patience they prove. The beginning worth honouring is the beginning that kept beginning. He thinks of futures spoken softly, a delta that will choose a new mouth and teach a city humility, a reef that will mend where hands and parrotfish share the labour, a marsh that will climb grain by grain to stay with a tide that walks higher now, a headland that will accept retreat and reveal fossils whose lesson is not extinction but duration beyond crisis. These are not predictions, they are promises that a living edge always tries. Night gathers, and the sea wears stars on its first skin. Somewhere beneath, a current shoulders past a sill and carries cold into warmth kindly. Somewhere above, a faint glow traces the aurora's patient curtain. He opens his eyes and does not look for closure. He lets the chord continue and chooses to listen as he goes. The journey back was a journey in, and the margins have given him a way to carry time, not to hold it still, but to move with it well. End of script. Sweet dreams.